Hello everyone and welcome to this video where we will discuss Kotlin development. Okay, so at the beginning, I want to kind of give you an overview of what this whole video will contain. So first of all, we will discuss Kotlin language foundations. Okay, so we will go from kind of a complete beginner, let's say somebody who has never built anything in Kotlin. We will discuss how we can get started, what the concepts are, how the language is built, and how we can use it to build various things, either various scripts or small programs, or more likely you are here because you want to learn Kotlin for Android development, so we will see how to do that. But also, this video is suitable for people who have some development experience, maybe in some other languages, but want to learn how to build things in Kotlin. Okay, so maybe you're coming from, let's say, a Java background and you want to kind of understand how Kotlin does things. Kotlin is very, very similar to Java, so it will be very easy to kind of pick up. So you are in the right place. Now, before we get started with actual Kotlin development, there's two kind of courses that I want to promote here because this whole video is a part of a course that I have built, it's actually part of two courses that I have built. First of all, it's part of the complete Kotlin development masterclass, which contains a lot more information about Kotlin development. Okay, so for example, this video, I think it has about 6 or 7 hours. We'll see how long it will be in the end, but this course has around 30 hours. Okay, so there's a lot more information. There's a lot of practice exercises. There's a lot of projects that we work on. So do check that out if you're interested. The second course is the Android course, which of course, if you're learning Kotlin, then you are likely interested in Android development. So I have a much larger, much broader course that has over 50 hours now, which is the complete Android and Jetpack Compose masterclass. So let me just show you these two courses because I have put them on my website here. So you can find the website here, but also down below in the description. And if you come here, let's say we are interested in Kotlin, I'm going to click on that and I'm taken to the course page. Okay, so here you will see that we have about 30 hours, a lot of resources, and here you might find some description about the course and what it will contain. And also, if you're interested in the Android course, there's some information here for the Android course as well. This is a lot more complex because Android contains a lot of functionality. There's a lot of things that we can do. So here we have a lot more time or rather videos to discuss all aspects of Android development. So do check those out if you're interested, but in any case, this video is self-contained, so you can just follow along and learn Kotlin from this video alone. All right, so with that said, let's get into Kotlin development. Now, in this video, I want to talk very briefly about what we will see in this section. So first of all, we will talk about some foundations, things like variables, strings, operators, logical operators, true, false, things like that. Foundations in Kotlin, we will cover those quite extensively. Then we will move on to things like flow control, functions, lambdas, loops, if statements, things like that, right? So these are all very basic things that we need to know and understand in order to be able to develop in Kotlin and in Android, obviously. Then we will move on to object-oriented programming. Now, OOP is a huge topic, and I don't really have time to do it justice here. As I mentioned in the other course, there's a lot more detail, a lot more information, and a lot more exercises and practice opportunities. But here I do need to introduce some concepts like classes, interfaces, and various concepts within those classes. Okay, so like constructors, like initialization blocks and things like that. Okay, and we will spend a few videos on talking about object-oriented programming. And then finally, kind of peppered throughout this section, we will have a lot of exercises. So both exercises while we are learning about the topics, but also after we learn certain topics, we have practice exercises to kind of solidify a little bit the concepts that we talk about. Okay, so hopefully you will find this section useful, and if you've never worked with Kotlin before, it is absolutely necessary to have a good understanding of this in order to build applications on Android development. Okay, so with that said, let's go ahead and start learning about Kotlin development. Okay guys, so in this first video, we're going to go ahead and install everything we need for our Kotlin development. Okay, so the first thing we're going to need is we're going to need to install Java. If you've already worked with Java before, then you might already have it installed on your machine. So if that's the case, then you can skip the Java installation. However, if you've never worked with Java before, or if you've never developed or did any programming before, then you might want to install Java. So to do that, we're going to open up a browser window and we're going to search on Google for install Java. Okay, if we search for install Java, then we will get this suggestion. For me at the moment, it's my second suggestion here, and it is oracle.com/java/technologies download. Okay, downloads with an S. So if I click on that, that's going to take me to a download page where you have the option to choose which system you are running on and download the appropriate archive here to install on your machine. So for me, for example, it would be Mac OS, and I think I would be on a x64 DMG installer, right? So I would download that. Now for me, I already have that downloaded, but for you, just go ahead and click on that, download the package and install it locally. Okay, once you have that installed, just open up a terminal window. Okay, and if we type here java -- version, then that should give you the current version, right? So for example, here you have Java 18. That's the latest version that we're going to use here. All right, so that is one installation. The second one that we're going to need is we're going to need this IDE. An IDE is basically an integrated development environment. Okay, so the one we're going to use for Kotlin development is IntelliJ IDEA. The reason why we're using IntelliJ is because it is very similar to Android Studio, and in fact, Android Studio IDE is based on IntelliJ. Okay, so we're going to use both because they are very similar, so we get used to them. IntelliJ, in order to download that, simply go to another browser window here, and we're going to search for IntelliJ IDEA. They added an A at the end to make this word idea rather than IDE, but you know, that's the same thing. You're going to find this website JetBrains. That's the I think it's the company that developed it. In any case, we're going to have IntelliJ IDEA, and on the first page here, I have a download button. Let's go to that. Now here, make sure you download the community version, right? The ultimate is a paid version, so we don't want that. We want a community version. It is JVM and Android development. Okay, for Android development, we're going to have a separate IDEA that is specific for Android, so don't worry about that for now. Just make sure that you are on the right tab here: Windows, Mac, or Linux, Mac OS, download and install that package, okay? Or Windows if you're on a Windows PC. All right, so go ahead and download and install that. And if once you've done that, just open it up and you will see something similar to this, okay? So this is my IDEA at the moment. We're gonna go ahead and create a new project here. And we're gonna we're gonna name it something like Kotlin tutorial. Whatever your name, whatever name you want to give it, that doesn't matter. Now, importantly here down below, we have language. So make sure you select Kotlin for the language. The build system is IntelliJ and the JDK is going to be 1.8 installed for me. If you don't see 1.8 here, then you'll probably find it here in the selected detected SDKs. So make sure you select it from there. But for me, I have it here, 1.8, and then I'm going to click create. And it's going to take a moment to download everything and index a few different files and create the project and so on, right? So give it a bit of time for that to finish. In any case, this is our development environment. Now, I want to take a bit of a moment to kind of run you through a few of the options that we have here in the environment, because they will come in useful later on. So first of all, if we click here in IntelliJ IDEA, we have our preferences. Okay, so for the preferences, we have a bunch of options here. Just go ahead and check them out if you like, get accustomed to them. You can also search for a preference if you like, if you're looking for something specific. I just wanted to show you one option, and that is the key map. The key map is very useful because it shows you the keyboard shortcuts that you can use while you are developing. And at the beginning, you may not use a lot of them, but as you go through and learn development and work with this environment, then it will become very useful to perform some operations with the keyboard rather than with the menus up here. All the options are in the menu, but it's easier with the keyboard. So check those out if you like. You also have here some plugins. I have installed a plugin called Presentation Assist. So that will give you, let me actually just show you how that works. That will basically allow you to see the keyboard shortcuts that I use down below here. So before I show you that, let's go ahead and create a new file. You will have a bit of a structure to your project. We have the project files.ida, actually the IDE files. Then you have the source, which contains all the project files. In the main, you will build your Kotlin files, and in the test, here you might put unit tests and other things. We're going to use that in Android. We're not going to use that for Kotlin. So let's skip that for now. And then you have some dependencies, libraries, and so on. So the main folder that we're interested in is the source main folder. And inside we have a Kotlin. Okay, so here I'm going to right click and create a new Kotlin file. Okay, and I'm going to call this hw.kt. HW comes from hello world and KT for Kotlin. Okay, so let's run that. It added a class. I don't want a class actually. I'm just going to remove everything here. You might have this error as well. It says JDK 1.8 is not found on the disk. If you get that, just go to File and Project Structure. Okay, and here I have an SDK, so I'm not really sure why we get that issue, but let me just select the OpenJDK here. Okay, close this and open it up back again, and that should fix the issue that we're having. Okay, it's just indexing. So if I have a look here, it's just updating something in the background. That is fine. We're gonna keep on with the video. There we go. So the first thing that we need to do is we need to write a program to write out a hello world application. Okay, just something that prints out a string called hello world. The reason why we print out a hello world is basically tradition. Whenever we start learning a new development language, what we want to do is we want to jump in and start coding with a very, very simple, very basic program. And the most basic program in pretty much any development language is to write out a string to the console. And by custom, that string is going to be hello world. So we're going to stick to that tradition in Kotlin as well. One more thing I wanted to say is that I need to introduce a few concepts that obviously we haven't talked about since we are at the beginning of the course, but I will explain them in a bit of detail now, but also later on when we tackle those concepts, right? So for now, we're just going to type out the code. and then we're going to explain it, right? So first of all, we're going to say fun. This is short for function, and we're going to call our function main, open parentheses, close parentheses, open curly bracket, close curly bracket. And inside here, we're going to say print ln. And if you wait a little bit, then you will get these suggestions, okay? Print ln, and you have all the options available to you. So I'm going to select print ln, and inside here, I'm going to put double quotes. And inside the double quotes, I'm going to say hello world. Okay, save that. Now, if I save, well, two things I want to mention. First of all, the save is automatic. I'm just kind of used to saving because I often develop in other environments for different languages. For example, in Visual Studio Code, you have to save manually. So I'm kind of used to typing Command S. But also, importantly, here you will see the keys that I typed for Save All. Okay, this is the plugin that I was telling you about, the Presentation Assist, that will let you know what I'm typing on the keyboard, right? Even though you don't see the output here in the file, you will see it down below. Anyway, we have our program. So let's go ahead and run our program and see the output. To run the program, it's actually very simple. On the top right side, you will have this green play button, and that if you hover over it, it will say run hw.kt. So let's go ahead and click on it. Okay, you can also have a keyboard shortcut if you prefer, but let's just run it like that. I'm going to wait for this to finish in the background, and then we get our console down below. Okay, you see here the tab run. There's many tabs that we're going to use throughout our course, but for run, we have the output hello world. Okay, so very, very simple program, but at least we know that everything works from start to finish. We can use Kotlin, we can use Java, we can use IntelliJ to actually run our program. Okay, so that's what I wanted to do in this first video. We have installed everything we need for Kotlin, although we will need additional stuff for Android, but for now, we can go ahead and learn about Kotlin in detail. So that's it for this video. Thank you for watching, and I will see you in the next one. All right, so in this video, we're going to continue on with the code that we wrote last time. We're going to update it a little bit just to kind of change it. And then we're going to go into talking about comments, which are very, very useful for us as developers. And we will see why that is. Now, the code that we wrote last time, it is very simple, very basic. But still, if you've never built a program before, if you've never developed anything before, then you might have a few questions what all these words actually mean. So I'm going to go over it a little bit in kind of a high-level detail, kind of high-level overview. We will talk about all of these keywords later on. But you know, for now, I just wanted to kind of make it a bit more clear what this code is and what it does, right? So first of all, we have our keyword fun. The fun keyword basically stands for function. And it is basically a piece of code that we can run multiple times, as many times as we like. In our code, this is our only function, and this is what is run when we actually run the program. But in reality, in a larger project, then we have many, many functions, and we call them whenever we require their functionality, right? So that is how you define a function with the keyword fun, and then the name of the function. For us, the name is going to be main, because it is our main function, our main entry point into the program. Of course, we will talk a lot more about functions when we reach that part of our course. But for now, let's just have a look at what the function does. So first of all, we have these parentheses. Now, you might wonder why we have those. Basically, here is where we can pass any parameters, any values, any variables that we will study later on. We can pass them into our function so that we can use them in our code. For now, we have no parameters that we need to pass, so the parentheses are empty. However, the function name and parameter part is followed by the code block. Okay, the code block is delimited by curly brackets. And here we have the open and the close one. We have to have this pair so that the system knows that the function is limited to whatever it is between these two curly brackets. Now, inside here, for our code, we only have a single instruction, which is println. Println basically says that we want to print something to the console, to whatever the output is. In our case, we haven't defined anything else, so it is the output console. We want to print something, and this ln stands for line. So at the end, we will print a new line here, right? If we only do print, and then we do another print, let's say hi, these will be right next to each other, right? So let me just run that real quick. And then we will get hello world hi. So there's no spacing between, there's no new line here. But if I put a ln here, then running that will put my hi down below. Okay, there's just a new line that is created here. Very, very simple. Okay, now inside the print line function, by the way, this is also a function. This is a function that is part of Kotlin, but a function nonetheless. And you can see here that in my function call, here is where I call this function. I pass one parameter, which is a string. A string is basically just a string of characters. In our case, that is hello world. Okay, now what I would like to do is I would like to ask you to pause the video and update this code so that instead of hello world here, you will get the output hello and your own name. Okay, so update the code to put your name here instead of world. Pause the video now, update the code, and then come back and I will do the same thing. All right, so hopefully you have done that. For me, I'm just going to update here. Instead of world, I'm going to put Kotlin, that is my name. Hello, Kotlin, and then I'm going to run my code, and that should print out a hello message for me. All right, so very simple, but it is quite important to know what the code does, even at this very simple, very basic stage. All right, so now let's move on to comments. Now, comments are basically an explanation about the code that we are writing, okay? Comments are not interpreted by Kotlin. They are completely ignored. They are simply there to inform whoever is reading our code what the code does, or anything that the developer wants the reader to know, right? They are basically, usually there are explanations about code, but they can be pretty much anything. They can describe anything. They most commonly explain what a piece of code does. Sometimes you will get comments like, do not touch this piece of code because it's very complicated, whatever. That is a message to the reader. However, usually good comments will explain what that code does and why it was created. Now, we have basically two types of comments. We have a single line comment, and here to write a single line comment, we have a double forward slash. Putting a double forward slash in your code basically says that the compiler needs to completely ignore what is afterwards. Okay, so that is the single line comment, and we also have a multi-line comment, which is /*. We have our comment as long as it needs to be. There are no limitations. And then at the end, we have */. Okay, so everything that is between these two characters, that is going to be ignored by the system. So let me just put a comment here. So for example, I'm going to put a single line comment. This code prints out a greeting. Okay, now the comment here is not particularly necessary since this is very obvious, but that is how it works. If we run this, it's going to do exactly the same thing that it did previously, because this line is completely ignored since it is a comment. Okay, and we're going to also add a multi-line comment. I'm going to add it here. Okay, and you can see the end character was automatically generated. this is the first code that is by convention written in a new dev language. Okay, running that again, that gives us the same output, obviously. So that is all regarding comments. We're going to use them quite a lot, both in this course and you're going to use them in your usual development. I wanted to show you one more thing, and that is the keyboard shortcut for creating a comment. So first of all, let's say we have a line here in our code, print ABC. If we run this, we're going to get some ugly output, right? We're going to get ABC hello world. That's going to kind of not be ideal. So let's say in the process of development, we want to comment out this code, okay? Comment out simply means that we convert a line of code to a comment so that it is ignored by the compiler and basically removed from execution, okay? So what I could do is I could put // here at the beginning, and that will work fine. I have commented out this line of code, but we also have a keyboard shortcut that is very useful, and that is command on a Mac, command // or on a PC, I think it is control //. So if I hit that, comment with line comment, control / for Windows. Okay, so that basically comments out this piece of code. And if I do that again, it will basically remove that comment. And we can also comment out multiple lines. So for example, here I have selected 2 lines and I have commented them out and remove that. Okay, or if I just go line by line, I'm going to go // and remove basically everything. And if I do command Z or control Z, I will undo that comment. Okay, so just kind of play around with the keyboard shortcut. It is very useful. It's one that I use pretty much on a daily basis, and you will find it very useful as well. All right, so that is all for this video. That is all for the hello world and the comments. Thank you for watching, and I will see you in the next one. Okay, so before we move on with the course, I want to make a suggestion that is quite often done for developers, and I am one of those developers who prefers it. That is basically to change the theme of your IDE. Okay, let me just show you what I mean. So if you go to IntelliJ IDEA and go to Preferences, now here under Appearances, Appearance and Behavior, under Appearance, up here, you have Theme IntelliJ Lite. If you click on that, I usually switch to Dracula, okay? That gives you a kind of a dark theme, and that for me is kind of easier on the eyes when you are developing for a long time. It's easier to watch darker colors than that light color shining in your retina all the time, right? So if you're developing for like 8 hours, 10 hours a day, you will be glad that you switched to Dracula. However, this is completely optional. This is a personal preference. Some people prefer light, some people prefer dark. I personally like to switch to the dark theme, so I'm gonna leave it like this. I find the colors a bit easier on the eyes, but feel free to choose whichever theme you like, or you can even develop your own theme if you prefer. Okay, so go ahead and play around with these things. You have 4 default themes here. You can, I'm sure you can find online more themes to install if you like. I'm going to continue the course with the dark theme, but for you, feel free to keep the light one if you prefer, or switch to dark as I do. Okay, so in this video, we're going to talk about variables. Now, variables are obviously very important. They are basically containers for data. Okay, so we have a container for a particular piece of data that we can manipulate, send over to a function, print out to the screen, or a huge number of other possibilities. Okay, it's just basically a handle on a piece of data that we give a name to. Now, in order to create a variable, we have this keyword var, and we have the name of the variable. So for example, here we have var dogs equals the value 3. Okay, for example, in this variable, we have the number 3. We also have a variable, something like TV shows watched. And in this example, we have the string many. Okay, so we can give different values to our variables. So this is how we create, or sometimes called assign, a variable. Assigning and creating are two different things. So creating is the first part, kind of var dogs, and assigning is basically giving that particular variable a value. Okay, so in this case, value is 3. We assign the value 3 to the created dogs variable. Okay, now changing a variable is obviously possible in some situations. So for example, here we have age equals 25. We create the variable, then we provide the value 26. Okay, that basically changes the value of this age variable. Okay, so now the age variable will have the value 26. We can also use the age variable to create another variable. So here, for example, new age is going to be my age variable plus 1. Keep in mind that in this case, age doesn't change. It's simply the result of this operation will be given to our new age variable. Okay, so let's go ahead and try that out in our code just to kind of get a handle on using these variables. So let me just go ahead and create a new file, and I'm going to call this variables.kt fun main. Okay. And here, let's create our variables. So for example, var age equals 25 and age equals 26. Now, if I print line this age variable, okay, you can see in this case that we pass the age variable to our print line function. We'll talk about functions later on in the course. But now if I run this code, what do you think the output would be? It would be obviously 26. Okay, so I can use this age variable to create a new variable. So let me just add it here before the print line. Var new age equals age plus 1. And then if I print age and then I print line new age, okay, we will see that age hasn't changed, it's still 26, but new age is age plus 1, so it's going to be 27. Okay, so let's go ahead and run that. Okay, so we get 26 for the first one and 27 for the second one. Okay, so these are the variables. Now, in actuality, we have two ways of creating the variables. First of all, we have the type that we've already learned about, the var, which is a changeable or mutable variable. But we also have another type, which is a read-only or immutable variable. These variables are usually for, or are always for, values that never change throughout your code. The difference between them is the way we create them. We have a keyword var for the changeable, and we have another keyword val that comes from value probably, and that is the read-only immutable type. Okay, so here, for example, let's go ahead and create a couple of things. So first of all, let's say var color equals, I'm going to give it a string of blue. Okay, so that works. Now, if I say color equals red, that works fine, right? Print line, we've already seen this, print line color. We are allowed to change variables that are defined with the var keyword. So now when I print out, I will get the red color. However, if I use val for color 2, let's say, and here I have blue, if I try to change this, color 2 equals red, well, that is not going to work. And you can see the red line here. If I hover over it, that's going to give me the error message, val cannot be reassigned. So this is basically a value that cannot change. Once we provide a value to it, that value is set in stone and cannot be updated. Okay, so here we get color blue, color red, that's fine. But if we have a val, we cannot change that value. All right, so let's talk a bit about naming our variables, right? So the names of our variables can be pretty much anything as long as they contain only letters, numbers, and underscores. Okay, you can pretty much give your variables any name you like. However, there are some restrictions, and some conventions. Okay, so let's go through them. So first of all, the names must start with either a letter or an underscore. A variable name can never start with a number. Okay, very, very important. Only letters or underscores. And names can be basically anything except Kotlin keywords. Okay, so for example, here we cannot have a variable named var. Okay, because var is already a keyword in our language, so we cannot use that name for a variable, right? So var equals 3, that's going to give us an error. Also, this example here, var println equals cat. Now, println is a valid name for a variable. However, it's kind of not a good idea to do that because println is not a keyword in Kotlin, but it is the name of a very commonly used function. Okay, and we've used it quite a lot. So println here, println here, println here, and so on. So if you give your variable name var println equals cat, yes, that's going to work, but that will cause a lot of confusion. So for example, if I want to do println, okay, that will work, but obviously that's not a very good idea, right? Let me just run that to make sure that works. There we go. So it works fine, but obviously this is quite confusing when somebody's trying to read your code. So it's best to avoid it. Now, the basic convention for creating variable names is what we call the camel case. Camel case is basically stringing words together, which with each word having a capital first letter. So for example, here, my dog is funny. You can see that the first letter of each word is capitalized. Okay, so that is what we call a camel case. There are some other conventions, for example, snake case, I think it's called, in which words are separated by underscores. But the most common case in Kotlin and in Android development is that you string the words like this. My capital dog is funny with capitalized first letters. There is another convention that is not so clearly defined, and that is basically the longer lived a variable is, the longer the name and more descriptive the name should be. I didn't put it here because it is quite vague. And it is a bit, we are kind of jumping a few steps. What is the longevity of a variable? That we will talk about later on when we talk about scopes and loops and functions and so on. So don't worry too much about that. Basically, keep that in the back of your mind somewhere, that if a variable you need it for a longer part of your code, then it needs to be more descriptive so that whoever is reading your code has an easier time understanding what you are writing, what your code does, basically. I wanted to mention one more thing. The order of definitions of your variables is important. So for instance, here I define color and color2. I cannot use a variable before it is defined. Okay, there are some programming languages in which you can define your variable anywhere and use it anywhere. But for Kotlin, I cannot use a variable before I define it. There's a linear progression in our code. So for example, here, if I define color2 here, I cannot use it before it is defined. So println color2 here, that is going to give me an error because the color2 has not been defined when the system reaches this line. Okay, so that is important to keep in mind, but that, you will kind of pick these up as you go. You don't have to kind of force yourself to remember these. These kind of make sense when you're developing. So you will get used to variables. Obviously, we will use them throughout our development career. Right, so that is all I wanted to say about variables. If anything else kind of comes up, we will tackle them as we go along through our course. But I think that's it for now. Thank you for watching. I will see you in the next video. All right, so let's talk about strings. Now, there's a lot to be said about strings, and we will use strings quite a lot in our development. So this is kind of a general introduction to the concept, but you will, of course, since we use it quite a lot, you will, practice it and learn it quite quickly. All right, so what are strings? So basically, string is a chain of 0 or more characters surrounded by double quotes. So here are some examples. We have cat, that is a string, a slightly longer string surrounded by double quotes, that is perfectly fine, and also a empty string. Okay, so that works as well. We've seen strings before, obviously when we worked with hello world. So here we have a string that we pass to our println function, and that works fine. That is a perfectly legitimate string, and that allows us to print something to the console. All right, now a string can basically contain any letter, number, character, or symbol except for double quotes and backslash. Now, double quotes is quite obvious since double quotes basically mean the beginning and the end of the string. Then inside the string, we cannot have a simple double quote. That will basically tell the system that the string is over, so that kind of makes it unreadable, let's say. Also, backslash is not allowed, and we will see shortly why. Now, if we do need our string to contain a double quote, then we need to quote unquote escape it. And to escape a character, we simply place a backslash before the character. So let's go ahead and try this out. I'm going to create a new file here, new file, and I'm going to call this strings.kt, and I'm going to say fun main. Now here I want to print out a string, so print line, the answer is, and here I need to put something like yes. Okay, something like that. But you can see that obviously this will not work, but we need to, as we say, escape it with a backslash. So I'm going to put a backslash before my quote and before my second quote as well. Okay, so that allows us to introduce a double quote in our string. Okay, so let me go ahead and run this. And the output is going to be the answer is yes. Okay, now you can now see why backslash is not allowed as well, right? So here we have a string can contain any letter, number, character, or symbol except quote and backslash, because backslash is the escape character. But what if, let's say, we do need a backslash in our quote? Well, obviously, we're going to need to escape that as well. So print line, I need to put a backslash in my code. Okay, so here I want to put a backslash, so I'm going to escape it, which means I need to double it, right? So escape backslash. Okay, so if I run that, I'm going to have a backslash here in my code. So a double backslash here is interpreted as a single backslash in the output. And of course, if I need to put 2 backslashes, then I need to double that. So I'm going to have 4 backslashes here, and I'm going to have 2 backslashes in my output. Okay, so that allows us to put quotes and backslash in our string as well. All right, so a double backslash in a string is interpreted as a single backslash. All right, now let's talk about templates, because templates are extremely useful when we are passing strings around or we are building strings from our variables. So a string in Kotlin can contain an expression, which means that the expression is evaluated and inserted into the string. So how does this work? Basically, we have an expression that starts with a $sign and can contain braces. Okay, so let's have a look at what this means. So for example, here, let me define a variable dog name that's going to be Teddy. Okay, and I want to print this dog name that, let's say, comes from another part of our program. We're going to assume that, and I want to print it in my string. So I'm going to say print line, my dog's name is, and here I want to put Teddy, but I don't want to type it out, okay, because this name, this variable might come from another part of the program and might have whatever value it has here. So I do need to print out the value of this variable. So instead of typing it out here, I'm going to precede it by a $, and I'm going to say dog name. Okay, so that should work fine. If I run this, the system is going to replace this variable name with the value, and that's going to be by dog's name is Teddy. Okay, so that's what we mean when we say an expression can start with a $. Now, what about the braces? Well, let's say we want to put a arithmetic operation here. So I'm going to say print line. Let's say I have, and here I want to put my expression, $ curly braces, and I'm going to put first, I'm going to complete the string here, cats. So let's say for some reason I want to add two numbers together here. So I'm going to say 1 plus 2. Okay. Now this is an expression, 1 plus 2. We haven't studied expressions. It kind of makes sense since it's basically a very simple math expression, but we haven't studied them. Don't worry. We will get to them later on. But if we have an expression, we want to put it in our string. It's not enough to precede it with a $. We need to put the expression inside curly braces, okay? So here I have 1 plus 2 cats. The interpreter is going to interpret this expression and give us the result. So let's have a run. Let's run our code. And here we will get, I have 3 cats. And you will notice basically that this is a shorthand version of this. So in actuality, I could put curly braces here and that will work just as well. But this is more simple. It's an easier way to just remove the curly braces. So since the system will already know what I'm trying to do. Since this is not an expression, this is a variable. Okay, so those are the expressions. I have here my examples. Those are the templates. So basically anything you want to put in a string without $. Now you could also do something like this, by the way. You can also say print line, my dog's name is, close my string, then add a plus dog name. I need to put a space here, and I could add another string, and I love him very much. Okay, so I could create the string like this. Okay, if I run this, that's gonna work fine. This is called concatenation, and strings can be concatenated like that. So you can see the output is working as intended. But this is kind of complicated, especially if we have multiple expressions, multiple variables that we need to put inside a string. So this is a far superior way to do it. So let's say I put here a $, dog name, and then everything goes inside my one string, and I don't have to worry about quotes and pluses or anything like that, right? So easier to do it this way. Okay, so that's all for my templates. Now let's have a look at a few functions for my string. So for example, I could get the length of a string. Length is a property of a string, so I can always call it with dot length. Okay, so here I'm gonna say, let's say val my pet equals crocodile. Okay, and I'm gonna print line my pet dot length, length. Okay, so that will basically give me the length of my string. Let's see, we have 9. Okay, so that is a property. Now we have functions as well. So for example, capitalize. Let's say we have a variable Michelle that is kind of written in a weird way. Let's say we allow the user to input whatever they like there. So the variable can contain lowercase and uppercase letters, right? So val my name is Michelle LLE. Okay, so just random uppercase and lowercase letters. And I'm going to say print line my name dot, let's say I want to put everything in uppercase. Okay, if I run that, okay, that is going to give me uppercase letters. So this is a property, this is a function. The difference between the two is that we need to call a function with these parentheses, right? This is how we call functions in Kotlin, in Java, in many other languages. Again, we haven't talked about functions yet, so don't worry about that. We will get to them later on, but just keep in mind that we can apply some functionality to my variable. Keep in mind that the variable itself doesn't change, okay? So if I just print line my variable here, my name, it's going to be the same. It's going to be Michelle. So the function hasn't changed the variable. It's just that here we print the result of the function. Okay, so the result of the function is given to my print line function, and the variable stays exactly the same. And we also have a bunch of other functions. So for example, my name dot lowercase will put everything in lowercase letters as well. Okay, I hope that is clear. So we have capitalize, decapitalize. Now, I want to, before we finish this video, I want to give you a kind of a tip on how to find all available functions for, let's say in our case for strings, but this works in a very generic way. So let's say we have print line my name, and I want to apply some functions, but I don't really know exactly what that function is. So here, if I type a dot, I will get a pop-up with the suggestions for the available functions and methods and properties of that, that variable, right? So here I have my property, here I have my function, but here I have everything. It's completely exhaustive. So if I go with my down key, and if I scroll through this, I will find a lot of functions. Okay, so I'm not going to go into what all of these do. You will, when you need a function, you can simply search through this list, or simply Google to see if that functionality exists, so you don't have to implement it yourself. Okay, so there's a lot of functionality. Most of these require concepts that we haven't talked about yet, so we're not going to go into these details, but just know that they are there, right? Let me give you an example. Here we have, let's say we have trim, and trim basically removes any spaces or new lines at the beginning and at the end of your string. So here I have a space, here I have a tab and a space. Okay, if I run that, okay, you can see that the uppercase maintains the white space. Okay, we have the beginning and the end spaces, but trim does not. So trim has removed those white spaces. And this is very useful when we allow our user to input some data from a form, for example. If they put white spaces, then that might cause a problem. So we should always trim our string before we process it in other ways. Okay, so that I think is very useful to know how to get all the functionality, all the functions available for a particular string, but not only, we will see later on how we can use that pop-up for other things as well. All right, so that's it for this video about strings. Thank you for watching. I'll see you in the next one. In this video, we're going to talk about data types in general. And we're going to narrow our focus just for this video on a particular kind of data type. You will see shortly what I mean. So we have a few different data types in Kotlin. Now we have what we call primitive types, and we have complex types. The complex types are going to be composed of primitives, and we are going to talk about these later on. But for now, we're just going to talk about the very basic, very foundational types of data that we have and that we can assign to our variables. So first of all, the one that we've already used quite often is string, okay? So we've used strings, we have a good idea of how strings work, what they are, and so on. They are kind of complex types because they are composed of characters, and you can actually, we will see this later on, but you can actually access the individual characters very easily as if it was an array of characters. But let's think of it as a data type for now, since it's very basic and we can assign it to variables. We also have Boolean, which means either a 0 or a 1. It's usually a flag that you can kind of turn on and off and make some logical operations on. And we will cover the Booleans in, I think it's not the next section, but the one after that, because there's a lot to talk about when it comes to Booleans. And finally, we have numbers. Now, numbers are going to be the focus of this particular video. And we're going to go into details about what kind of numbers we have available in Kotlin. Now, numbers in Kotlin are very similar to the numbers in math, okay? So you have positive numbers, negative numbers, floating point numbers, and so on. Numbers can be assigned to a variable in a similar way to how we've assigned strings to variables. We can assign numbers, and we can perform some operations on them. We will talk about operations in the next video or the one after that. But basically, mathematical operations can be applied to numbers, and the result of those operations can be again assigned to another variable. So let's try this out real quick in our environment here. So I'm going to create a new file, numbers.kt, fun main. Okay. And let's go ahead and create 2 or 3 variables rather. So val price is going to be $12.99. Okay, let's say we have some product that we're selling. We have val price is going to be, val amount is going to be, let's say 3. And then val total is going to be price multiplied by amount. Okay, so let's go ahead and print out the result of this operation. So print line, here we have total is $total. Okay, now let's leave it here for now. Yes, let's leave it here for now and move on. We'll come back to it. So we can perform operations on numbers and variables. Now, let's have a look at the types of numbers that are available. Okay, so here we have, we've seen 2 types basically. We've seen a integer number and a floating point number. And we have those types in Kotlin. Now, Kotlin, compared to other languages, has fewer types that are defined by default. And that is actually, in my opinion, quite a good thing, because when you are developing your code, you're not going to focus too much on pinpointing the exact memory size of the variable that you want. You're just gonna want to assign a value to a variable and move on with your life, right? So the number types in Kotlin are 4 in numbers. So we have the byte, which is stored in memory as 8 bits. So that gives us a minimum value of -128 and maximum 127, since there's a 0 there that takes up one value. We have the short, 16 bits in memory, -32,000 whatever. We have integer, 32 bits, and it has to be between these 2 values, which are quite large, and usually that's basically all you need. And then finally we have long, which is a much greater value. And normally you would use this for highly specific domain applications where let's say you're building a math program or a plotting algorithm or something very specific, right? But in general, you're not going to use long, you're going to use the integer. Also, we have 2 types of floating point numbers, okay? We have float and we have double. basically here, for example, for the float, you have 32 bits. 6 or 7 of those are decimal digits. The other bits are for the for whatever is after the dot. Okay, and for double, it's 15 to 16. These values don't really matter. The main idea here is that you have to kind of know which types are available. In some situations, you might require specific types, but in general, and here's the important point, in general, you will deal with these two types, integer and double. Okay, if you want integer number, that's going to be the int. If you want floating point number, you're going to use doubles. Okay, so before we move on to the code, let's have a look at how we define the type of number. So we have two types. We have implicit and explicit. Implicit numbers are basically decided by Kotlin. So for example, if we create a variable val cats equals 3, you can see that 3 will kind of fit into many categories. It can either be a byte, short, int, or long. But by default, Kotlin will assign the type integer to our variable. Okay, val cats equals 3. It decides the most appropriate variable type based on the value you provide. So if we give something like 1499, that's obviously not going to be an integer because it has a floating point number as a value. So that means it has a floating point data type. However, the default is double. Okay, so it's not going to be float, it's going to be double by default. So these two are by default unless we specify exactly what type we want. So let's go ahead and try it out in our code. So here we have, let's say, actually we do have two variables that we have defined. Amount that we give a default value of 3, and that's going to be an integer, and price, that's going to be a double. So let's have a look. Here's a quick tip on how you can get the type of a variable. We're going to print line something like price, $price, and $expression, price, class.java. So this will give us the type of variable that this has been defined as. Class.java is kind of a weird expression, and you're not going to see it. You're going to see it quite often, actually. The reason why we have it in this way is because Kotlin is based on Java, basically, right? So some things that are not very common, very usual in Kotlin will kind of revert to Java functionality. So this double colon will basically refer to underlying Java functionality, and there we want to simply get the Java class. Okay, don't worry too much about what this means. Basically, it's just a way to get the type of variable, type of data that is stored in this variable. Okay, so that is for the price. Now let's print line the amount, amount, and we have an expression amount, class.java. Okay, so we have that. Let's go ahead and run our code and see the type of data that is assigned by default. So we can see that the price was double by default. Okay, we've just provided the value, and the system automatically inferred that this is a double type variable, and the same for amount. Amount is going to be an integer because we provided an integer. Okay, so that's how implicit type association works. Now we also have the explicit type, where we can instruct Kotlin to assign a different type to our variables, different from the implicit one. So for example, here by default cats is going to be 3, but if we want, let's say, dogs, which is going to be 5, by default this would be an integer, but if we want to define it as a byte, we simply have this structure colon the type of variable that we have. So here we define a byte. Okay, for example, we can define a short as 20,000. Remember that short can go from minus 32,000 to plus 32,000. Okay, So we have a short, we have an integer, we can specify it if we want to make it more clear in code what this variable actually is. We have a long, okay, and we have, okay, so here we have a different way to define, to give a value to our variable. This works for long and for float. So for long, if we put a capital L after our value, then that means it's a 42 long, and that will make our variable be defined as a long by default. Okay, so this is, the value is no longer an integer, it is a long. Okay, so we can actually try that out in our code. So let's define, let's say var dogs is going to be, let's define a type of byte equals 3, and we're going to print line dogs, $dogs, and $expression dogs ::class.java. And let's define a long. So similar to how we have here, life 42, life equals 42L. Okay, so we've provided the long value of 42. So that means the type is going to be long. So print line, and here we have life, $life, and the expression life : class Java. Okay, so let's go ahead and run this. We should get a type of dog that is a byte, and life is going to be long. Okay, so that is for the integer types. We also have the numbers. Here we define 599. This is by default, like we've seen earlier, this is by default a double. However, if we want a float, we have a capital F letter for the value, and that will be defined as a float. We can also simply provide the float type as we have previously, right? So in this way, :float. Okay, so here, let's say we, let's just check it out, try it out. Money equals, or let's define it as a float, 699 F, and then we're going to print line money, $money, and the type money : class Java. Okay, let's go ahead and run this, and we should get a float value here. Okay, so that is basically how types work. Of course, you will work with data types and variables and numbers quite a lot in your code, in your development, so you will quickly pick up these values. But the most important thing, I guess, is the default values, okay? The default data types, implicit definition. So by default, you either work with integer or double. The others are quite rare. These are the two most common ones. So now that we have talked about various types that we have available and about variables, let's have a look at how we can basically convert one type into another. So a variable of a certain type can be converted into a different type. This is actually quite easy, and we tend to do it quite a lot in our development. So let's have a look at an example here. Let me just create a new file. Type conversion.kt fun main. Right. So let's create a variable val cats equals 3. Okay, so let's say we have 3 cats. Now, this is an integer, as we've seen previously, right? The type is automatically given to this variable. So let's convert this to a long. So val long cats is going to be cats dot, and we have some functions to convert this variable to other types. So for example, to long, we have to long. We have the function .toLong. Okay, this can be applied to basically any type to convert into this new type that we are looking for. So if I do a print line here, and I will say long cats and class.java. Okay, so let's go ahead and run this, and we should get an output of long. Okay, there we go. So we have converted an integer to a long. Now, importantly here, we don't actually convert the variable itself. So cats.toLong doesn't mean the cats is now long. It just means that the result of this operation is attached to a new variable that will be of type long. Okay, so importantly here, cats is still going to be an integer, but long cats is going to be a long, right? So it's only the result. You can convert to a smaller type. So an important aspect here is that this is an integer and this is a long. A long is bigger than an integer in memory, right? So we can hold larger numbers in our long variables than in our integer variables. So that means if you convert a long variable into an integer variable, then be careful there because you might lose some information. Okay, so the Kotlin system actually lets you convert to a smaller type. It's just that you have to be careful yourself to not convert a large type into a small type when the small variable cannot hold all the information. Okay, so in order to have an example of that, let's see. So here, for example, we turned an integer to a long with the value 3, which fits in both types, right? So if we convert a long into an int with a value 3, that's fine because 3 will fit into an integer type. But let's create a variable that doesn't fit into an integer type. So for example, val people, let's say we have, I don't know, about 8 billion people, 7.5 billion people on the planet. 7, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is people. I want to show you a quick trick here because when you are creating a number that is just too big and you cannot read it properly, Kotlin actually allows you to put underscores in the number, okay, so that it makes it easier to read. Okay, so let's put this 7.5 billion people, and then this is automatically a long variable, right? So if I print line here, let's say people : class.java. I'm not actually looking for the value, so I'm just going to print out the type. This should be a long. Okay, now if we convert this to an integer, val few people equals people.toInt. Okay, and if we print line, now here I want the value as well because it's quite important. So if we print out few people and then dollar expression few people : class Java, you will see that since int cannot hold this large number, 7.5 billion, then we will get an undefined value here. Okay, we will get an exception or an error rather. So here you can see that we've converted a long into an int. The int will contain something like this. Okay, so that is a problem. There's a reason why this is exactly the value that is converted to, and it has to do with how many bits are stored in memory for an integer. If we overflow that, it's going to go back to negative numbers, and we need to be careful there. This is a long, this is an int. An int cannot hold all the values of a long, so that can cause a problem. Okay, so be careful with that. Any variable, okay, so that is all for the numbers. We can basically convert any number to any other type of number. We just need to be careful. But however, any variable can be converted to a string without any issues, right? So we just take the number and we convert it into characters that are part of a string. Okay, so here it's an example. We can convert our cats to a string. So 3 is going to become a string, same as, for example, here we have our pi. So let's define, actually, let's do this, print line, and cats.toString. And let's print out class.java. By the way, you can also chain operations like this. We will see this later on when we talk about functions, but these operations can be chained together if the result of an operation can have a function that is applied to it. Okay, but in this case, since cats.string class.toString has a type, then we can print it out like this. Okay, so let's go ahead and run this. Okay, and we should see a string. Now, for the string, the output is a bit different. You see here a class Java lang string. As I mentioned before, strings are not really primitive types. Okay, they are. We are thinking of them as primitive types and are considering them primitive types, but, and this is an important but, they are not primitive types. They are actually classes. And we will talk about these when we look at object orientation. In the meantime, let's not worry too much. Let's just treat them as primitive types, even though in the back of our minds, we know that they are not. Okay, so moving on, I wanted to define another variable pi equals 3.1415, and then we can convert this to a string as well. So this is a double, right? Because it was automatically, it's a floating point number, so it was automatically created as a double. So let's convert this to string. And let's print out the class.java. Okay, so let's go ahead and run that. And then we should get another string here. So basically anything can be converted into a string without having to worry too much. Okay, there's no limit to how large strings are. And here you have a list of all the functions to convert to different types. To byte, to short, to int, to long, to float, to double, to string. Okay, so go ahead and play around with these, convert some variables back and forth. Make sure you understand which types are bigger and which types are smaller. You can have some conversion issues when you are converting a large number to a small number, or let's say a floating point number to a non-floating point number. Okay, so you have to understand these and be careful when you are doing this conversion. After learning about type conversions, I think it's a good moment to talk about arithmetic operations, because these refer to basically all the types of numbers that we have in Kotlin, right? So arithmetic operations are basically your standard math operations. So we have addition. I have an example here. 5 plus 2 is going to be 7. That's very obvious. But also importantly, addition is the only one of all these operators that I'm going to detail here that applies to strings as well, right? So we have string plus string is going to be a concatenated string. Okay, so we have addition, subtraction, multiplication, and division, right? So these are very obvious. You kind of understand intuitively what they do. So I have here our examples: 5 minus 2, 5 times 2, and 5 divided by 2. Keep in mind that these are both integers, and the result of the operation is going to be an integer. If we have floats, doubles, then this is going to reflect that, right? So we're going to have a float or a double as a result. Then we also have modulus. Modulus is basically the remainder of our division. So for example, if we divide 5 by 2, we have the result 2 with 1 as a remainder, right? So that is the result of our modulus. And then we have increment and decrement. So increment plus plus, that's going to simply increment the value of our number or our variable. And decrement or decrement, it's going to do the opposite, basically do a variable minus 1, right? Importantly, the type of result of an operation is the same as the type of the largest operand. So if we have two operands that are different in type, so for example, an int and let's say a double, we can still perform the operation, except that for the result, we will have the highest type in terms of memory size, right? So in our example, int and double, the result is going to be a double. And the sizes are as follows. So byte, smaller than short, smaller than int, long, float, and double. So this is the order. Pick any two operands in this series, and you're going to know kind of what the largest size is going to be. Not largest size, but the size of the result of the operation, right? So let's have an example. Let's try that out in our code. I'm going to just create a new file here. arithmetic operations.kt fun main, and let's put that here. All right, so let's say val a equals 25, that's an integer, and val b is going to be, let's say, a double, 83.67. Okay, now if we do a val r equals a times b, okay, so we can perform this operation even though the types are different, but the result is going to be the largest type, which in our case is going to be our double. Okay, so let's verify that, print line. And here we have our result, and our result : class.java, which will give us the type. Okay, so let's go ahead and run this. Okay, taking a second to run for some reason. All right, there we go. So we have our result, and it is a double. Okay, so depending on what the types are of these operations, operands, the result is going to be the final type. Keep in mind that when we do something like this, the variables involved here, a and b, do not actually change in value. Okay, so we've seen this previously. Only the result of this operation is assigned to the final variable. However, there is an exception, actually two exceptions, and that is for the increment and the decrement. So for example, here we have a25, but if I can do here a++, the only thing here is that I've created a as a val, so I need to put a var so I can change the value. So if I do a++, then the value of the variable itself will be changed. So if I print a here, let's go ahead and run, and I should get a 26, right? And it's the same with a minus minus. So these are the only ones that change the actual value of the parameter or the variable involved. The others are simply going to give us a result that we can then use to attribute to another variable. Okay, so here you have the example that we talked about. We have the multiplication and the output type. Okay, so we have three more operators that we have already seen previously, and they're kind of intuitive. So basically we have the assignment, okay, in which basically we assign the value of one variable, for example, dozen, to another variable, for example, months. Okay, so here we have months equals dozen. So basically we assign the value of 12 to months. Okay, so very, very simple, very intuitive. Obviously, we've already done this many, many times, like here, right? So we assign the value 25 to our variable a. But I wanted to put it here for completeness. We also have the two operators that we use inside of strings. So we have our reference, okay, where we reference a variable inside a string, and we have our reference expression, and we reference the expression with curly braces. Okay, we've used this quite a number of times as well, and we will continue to use it because it's very useful. So these are the arithmetic operators. Finally, we also have a series of operators where we combine the assignment operator with the regular operators, right? The math operators. So let's take an example. For example, we have our variable var bikes equals 5, and let's combine our equals operator with the plus operator. So the new augmented operator, augmented assignment operator, is going to be plus equals, and that is basically going to increase the value by whatever we pass after the operator, right? So we have bikes plus equals 1, that's going to give us 6. Okay, so let's go ahead and try this in our code. So here var bikes equals 5. Make sure this is a var because we need to change that value. Bikes plus equals 1. And if we print line our bikes, okay, and that should give us 6. Okay, so that is 6. So these augmented assignment operators are also operators that act on the variable that they apply to, right? So here we have our bikes, and with this operator, we actually change the value of the bikes variable. Okay, so we have the plus equals, and we also have the other operators. So we have minus equals, which decreases the value. Plus equals and minus equals is equivalent, in fact, to the plus plus and minus minus operators. They are exactly the same thing. Their outcome is the same, except for plus equals, we can provide a different value here. So if we want, we can put any value, any long value, any double value, whatever we want. The plus plus only increments by 1, and this one, obviously, by any value we provide. Then we have multiplication equals, division equals, and modulus or percentage equals. Okay, modulus equals is going to give us, for example, in our case 5, modulus equals 2. That's going to give us the value of 1. Let's just try that out. Okay, here I have bikes modulus equals 2 and print line bikes. Okay, I have commented out these two because this will change the value of the variable. But here, if we don't have that, we have modulus equals 2, and that's going to give us a 1. Okay, so these are the operators. These are the mathematical operators. Okay. So we have math operators, arithmetic operators, the way we call them. We also have a number of other types of operators, and those are going to be the logical operators. And we will have a look at them in the next video. Okay, logical operators basically deal with a result of true or false. Okay, so you can kind of imagine which operators those are. Basically, a number is smaller than another number, but we will have a look at all of them in the next video. All right, so let's talk about logical operators. Logical operators basically means that we have an operator that will provide us with a true or false value. Okay, this is what Booleans are. Booleans are a type that can store only one bit of information, either 1 or a 0, either a true or a false, right? So logical operators act on Boolean values, right? So for example, we have here is day equals true, is night equals false. These are both Booleans. So what operators do we have to act on these two, let's say, variables? We have, first of all, we have the AND operator. That is a double AND sign. Okay, I don't know what you call this exactly, an AND sign, so double AND sign. So for example, here we have true and true. That's going to give us a true, true and false. That's going to give us a false. Okay, so I want to play around with these various operators that I'm going to introduce, and we're going to create a new file here. Logical operators.kt fun main. Okay, so there's pretty much any way you like to play around with these operators. So for example, you can simply print line true and true. Okay, so that should give us an output of true, even though this doesn't really make sense because this expression is literally always going to be true. But anyway, we can do that if we want. And actually, the IDE will tell us condition true and true is always true. Okay, so there's no variability there. It doesn't really make much sense, except in the context of learning about these operators. But we can also assign values to our variables. So for example, let's say we have a variable or a val is dog, and that's going to be true, and val is black, and let's say that is false, right? So finally, we have a value is or let's say black dog equals is dog and is black. Okay, print line black dog, and that's obviously going to give us a false because we have a false here. So true and false is going to be false. Now, I know this doesn't really make too much sense. Why do we have this AND operator here? What's the use of this expression? But it would be very useful when we will learn about if conditions, right? So when we can split the execution of our code based on a Boolean. So we can say if a expression is true, then we do something, else we do something else, right? If you want a sneak peek of this, I haven't included it in the slides because it's, we will learn about it later on, but we can do something like this. If black dog, then print line, I found, or a string here, I found a black dog, else print line, no black dogs around. Okay, so a sneak peek. You don't have to kind of learn this right now. We will have more information about this later on, but basically what this does is it says if we have a true here, then we do this. If not, we do this. Okay, so in our case, black dog is gonna be false. So that means we will perform this operation, so no black dogs around. So we should see that output, no black dogs around. But like I said, this is just a sneak peek. We're not going to use this right now. I just wanted to show you kind of where you can use these operators. And that's just one example. There's a lot more situations where you can use the logical operators. But anyway, let's continue on with other operators. So we have our AND, we have our OR, which is a double vertical line. Okay, true or false, that's going to be true. We need at least one of them to be true for the OR, right? So either this or that. Either true or false, this is going to be true. If both are false, then we're going to have a false. Okay, very, very intuitive. And we have the not operator, which simply reverses a Boolean. So not true, that's going to be false. Not false is going to be true. So I'll let you play around with these three operators as much as you like. Create a few Booleans, play around with them until you kind of get the hang of them. They are not too difficult. But anyway, let's move on to our comparison operators. These comparison operators, we can basically apply them to our number values or number variables that we've studied previously. So we have, first of all, we have greater than. So for example, here we have 3 greater than 2. That's going to be true. Smaller than, 3 smaller than 2. That's going to be false. Greater than or equal to. So 3 greater than or equal to 3. True, because it's equal, right? Or we could have a 4 here and that's still going to be true. And we have smaller than or equal to. So for example, 3 smaller than or equal to 3 is true because it is equal, right? If we had, let's say, a 2 here, then this would be false. Double equals is going to be, so for example, 3 double equals to 2 is going to be false. This checks the value. Okay, so there's a difference between our equality, which is assignment, and the equality check that gives us a Boolean. So for example, here print line is dog double equals true. That's going to be true. Okay, so this would be true. It's obvious because we've declared is dog equals true, but we can check is black dog, for example, equals true, and that's going to be false because this is going to be false and this is going to be true. So output is going to be false. Okay, so I hope that makes sense. And we have not equals, which is basically the opposite of equals. Checks that there is inequality there. So 3 is not equal to 2. Okay, now we can actually mix and match these comparison and logical operators. Okay, so you can chain them as much as you like. So let me give you a quick example here. Let's say we have a let's give a value or a variable age equals 15, let's say. Okay, and we want to check is teenager. So how do we check is teenager? Okay, so we could do something like age greater than or equal to, let's see, 12 is not a teenager, 13, because it has teen in the 13, that is a teenager. So greater than or equal to 13, and age smaller than, let's put just a strict smaller than, 19 is still a teen, 20 is not a teen, right? So this has to be less than 20. So age greater than 13 and age smaller than 20. Okay, and we can print line is teenager, and that should give us true because this is the value, this has the value 15. So we have true. Let me put this let me put a string here, just a bit nicer. Is teenager equals to reference is teenager. Okay, so that's going to give me a nicer output here. One more thing I wanted to mention is that when you chain these operations, you can actually use parentheses here, as many parentheses as you like. So for example, age greater than 13 and age greater than 20, we can put all of this in a parentheses, and we can say, if I add another variable here, is human equals to true, I can say and is human. Okay, so basically it will check the expression of this parentheses, then this parentheses, then between these two there's an and, so we will check that, and then finally the result of this is going to be compared to the is human because we have the and here. So that whole expression is going to give me is teenager. We can put is human here because, for example, if we have a dog that is 15 years old, you can't really say it's a teenager. So that kind of makes sense if you kind of stretch your imagination a little bit. And if I run this, since this is a human, then I will still get true. And if this is false, then even though this is going to be true, but we have an and is human, so this is going to be false in this case. Okay, so I hope that makes sense. Please play around with these as much as you like. They are not too difficult, but I think they may take a bit of time to kind of understand them correctly. All right, so that's it for the logical operators. Like I mentioned, we will use these later on when we talk about logical expressions and logical flow within our program. But for now, it's kind of useful and I think fun to play around with them to kind of understand them better. So try them out, play around as much as you like with them, and then we're going to move on to the next video. In the meantime, thank you for watching. I'll see you in the next one. In this video, I want to introduce the concept of nullability. Now, nullability is the idea that a variable can have no value present. Okay, so we define a variable, but there is nothing in it. We can say that that variable has a null value. Now, nullability is quite common in software development languages in general, and it actually poses a huge problem in other languages because when we try to access a particular variable with no value, or we try to perform some operation on that variable, that will usually give us a error or a crash of our program. Okay, so in order to kind of avoid that, Kotlin has developed some very strong nullability check mechanisms that will kind of prevent us, unless we do something on purpose, will prevent us from having a crash due to nullability. Right, so in this video, we will see what those mechanisms and checks are. So a null variable is a variable without any value present. And we use the null keyword to indicate this. So if we say the value of a variable is null, then it means that the variable has no value or hasn't had any value attached to it. Here is how we use that. So first of all, we define a variable cat name as of type string, and we need to provide this little question mark. This means that this variable can have the null value. So for example, here, if I provide the value fluffy for my cat name, then I can provide the value null. Okay, at this point, my variable will have no value attached to it. Even though we provided the fluffy value before, now we are removing it and we say there's no value there. If we don't provide the small question mark, then we cannot assign the value null to that variable. Okay, there is just no way to attach that. So in this way, kind of the system will know whether or not this variable can have a null value. The reason why we do have a null value possible and just not get rid of it completely is because, as I mentioned, Kotlin is based on Java, so it needs to be able to interoperate with Java 100%. Because we don't want to throw away old code. So that means since Java has a null value, Kotlin also has to have a null value, because otherwise we could simply just remove the null value and say every variable has a value, at least by default. So that will kind of remove a whole range of errors and crashes, right? But we are forced to use the null value, so we need to introduce this null keyword. All right, so we have a couple of operators for the null value. So the first one is the nullable check, right? So here, let's say we have a variable fluffy or a variable cat name with the value fluffy. We can get the cat name.length. We've already seen that. That works fine. However, if the variable is null, then we cannot get the length, because we cannot get a length of a null variable, right? A null value that will cause a crash. So in order to handle that for null values, as is the case on the right hand side, you can see the cat name has a question mark here. So this can be null. So that means we cannot simply do cat name.length as we've done here. So that means we need to have a special operator, which is going to be the question mark dot length. So this means basically either we return null if the cat name is null, or the actual string length. So the result of this operation can also be null. That is the consequence. But on the other hand, we can make sure that we do not have a crash in the program at this stage if the variable has a null value. And then we can chain these operations as we do for the simple dot operator, right? So cat name.length.toString, that is fine. If we have null values, cat name question mark dot let question mark dot string. Okay, so at this point, let's go ahead and put some code in our editor just to have a bit of practice with our null variables, right? So I'm going to say nullability.kt fun main, okay. And let's say var cat name equals fluffy. And if we want to make this nullable, then we need to provide it a type. So I'm going to say string, and I need to provide a question mark. So I can then say cat name equals null. And if I just go ahead and print the cat name, then I'm going to get a null output here. That is very obvious. Okay. Now, if I try to print cat name dot length, you can see that I have a problem. I get the error only safe or non-null assertions. We will see this shortly. Calls are allowed on a nullable receiver, blah, blah, blah. So that means we have a question mark dot length, or we need to provide the question mark dot length. This will tell us the expression is going to be always null because the editor recognizes that we have defined the variable here. But you can think of a system where a variable or a value comes from a third-party library and we have very little control over that. We don't know if it can be null or not, so that means this operator is going to be very useful, actually critical, in order to make sure that our program doesn't crash, right? So very, very important operator, question mark dot whatever. And the result of this expression will either be the actual value as an integer or the null value. So this is a nullable expression too. So if we want to chain another operation after that, then we need to use the question mark dot operator once again. So here we have dot toString, for example, right? We cannot simply say dot because this expression is nullable as well. So we need to check for that too. Right, so if we run that, then we will get null again. All right, now we cannot use classic arithmetic operators for null values. So things like plus, minus, multiplication, division, we cannot use those for null values because it doesn't really make sense. Null multiplied by null is going to give us a crash. So that means we will have replacement methods, and these are the methods. We have question mark dot plus for addition, question mark dot minus for subtraction, and so on and so forth, right? Dot times, dot division, and dot remainder. Okay, so let's try that out. Let's say I have a var amount of type int question mark equals 4. And then if I want to print out, let's say 4 times 3, I will say amount dot times 3. Okay, so that I need a question mark here, obviously, and that will give us the result, and that should be 12. Okay, so that is the those are the replacement methods for our standard operators that we cannot use for null values. Now, there are two more operators that I want to talk about. And the reason why these operators exist is because let's say we have, as we do here for Fluffy, let's say we have a null value or a nullable variable, right? And when I call catName.length, I can get, without the toString, I can get either the actual value or a null value. But let's say in my program, I really need a value here. If it's null, I want to have a default value, but if not, I want to have the real value. So this is where the question mark colon operator comes in. It's sometimes called the Elvis operator. You will hear this quite often. It's just because it's kind of sideways. It looks like like a little Elvis. But in any case, it simply provides either the actual result for a non-null variable or a default value. Okay, so this works in this way. For example, cat name is going to be null. So here, if our variable is null, then we provide a default value. This cat has no name. Okay, so let's try this out. Let's say print line, and I have here my cat name question mark colon. So Elvis operator. This cat has no name. Okay, so since we have our null value here, then we're going to get the default value here, okay, for the output of this print line. So this cat has no name. If the cat does have a name, so Fluffy, then this is going to be the actual name of the cat, right? So this allows us to have a variable, have a value, whatever the actual value of the nullable variable is, right? So we provide a default value. So this is the Elvis operator. Now we also have another operator that basically allows us to bypass all the nullability checks, right? And that is the double exclamation mark dot. So this will tell the system that me as a developer can guarantee, quote unquote, guarantee that there is no null value here. Even though the variable has been declared as a nullable, I can guarantee that there is no null value, so you can treat it as a non-null variable, right? So here, this is how this works. So for example, cat name is going to be string question mark. In this example, it's going to be null. If I try to guarantee that it is not null, and I try to get dot length, if the value is null, the program will crash. Right? So we need to be absolutely sure that this is not null. So here, for example, let me just remove the null. Even though it's a nullable variable, right? I can still go ahead and print line cat name dot length. And here I get an error. But if I just guarantee myself that this is not null, then this is going to work fine. So if the variable is not null, then I get 6. But if this is null, then I will get a crash. Now, the reason I don't actually get a crash here and I just get a IDE exception, the editor recognizes that I have set the variable myself, okay, to null. So it will not allow me to even run this code because it knows this is kind of a stupid code, so it won't work. But in reality, in a real world program where your value can come from other sources, let's say it comes from an API over the internet or a third-party library, you have very little control over that, right? So you can use this operator in a real world code. It's just that you need to be absolutely sure that it will not be null. Otherwise, it induces, it causes a crash. The only kind of reason I can think of to, want to use this operator is because the editor sometimes will give you a notice that this, a particular variable can be null. So if you want to bypass that, then that will work. There are some very edge cases where you might use this operator, but in general, I would highly recommend you avoid this operator. It's good to know that it's there, but unless you have a very, very good reason for using it, do not use it and simply use the $dot operator that allows for nullability checks and all the guards that Kotlin provides, right? It's not really worth the risk just to kind of, the rewards aren't really there. So unless you have a really, really strong reason, please don't use this. And I've put a warning here as well that this bypasses all the language checks and can trigger a program crash. Okay, especially if you have no control over what values are provided for particular variables. All right, so that is all for nullability. Actually, nullability in Kotlin is very, very useful because it simply removes a whole host, a whole range of crashes and exceptions in our code. So it's really good to be aware of it and use it as much as possible. All right, thank you for watching. I will see you in the next video. All right, so in this video, we're going to talk about exceptions. Now, what are exceptions? Exception is basically an unexpected event in a program. The main idea here is that something unexpected can happen. A variable can have an unexpected value or some crash occurs in the program, and then the system cannot recover. So that means we're going to have a problem where our execution simply crashes, our program stops, and that will lead to a whole host of problems. For example, data is lost, user experience is terrible, and so on and so forth, right? So when execution is stopped, data can be lost, we can lose track of where we are. Especially bad if we are at a critical point in our application, right? So for example, you can think of a banking application where you're processing a transaction. If your application crashes, then that can cause a huge problem. And it can cause a very bad user experience no matter where your application crashes. You obviously have experience of applications that have crashed while you are using them, and you can understand how frustrating that can be from a user perspective. So let's go to our editor and let's try to generate an exception. Let's see how that might work. So let me just create a exceptions file. Okay. And I'm going to say main function main. Okay. So let's create a variable. Let's call it amount equals, and we're going to make this a string 15, right? So we can print line this amount dot to int. Okay, so basically the string will be converted to an integer 15 and it's going to be printed out. That works fine. Okay, so we have 15, but let's change this to a variable and I'm going to change amount to ABC. Okay, what do you think will happen when the system tries to convert the string ABC to an integer? Well, obviously it's going to cause a problem. Okay, and that problem is an exception, and more specifically, it's a number format exception. The format of the number is incorrect for input string ABC. Okay, so toInt, this function caused an exception. Okay, so we need a way to handle that because at this point our program just crashed. If I try to print line something here, more execution here, okay, that is not going to be run since our application simply stopped at this point where the exception happened, okay? So we need a way to kind of handle that and continue the execution regardless. So here is our example, and here is our crash. Now, exceptions have a few things. So first of all, they have a message. Here our message is for input string ABC. They have a stack trace, which is a log of what the execution was, which steps the program went through before the exception happened. So here, this is our stack trace. And actually, this is very useful for us as developers when we are facing a bug in our application, a bug that causes an exception, a crash. It's very useful to check the stack trace to see where the exception occurred. So for example, here we see that the program went through main exception.kt, which is the file that we are running, and then it went to exception.kt:4, which is line 4 in our main file. So if we look at line 4, we can see that it is in fact the line that caused our exception. So you can think of a program or an application that has thousands or tens of thousands of lines. You would like to know exactly the line that caused the exception so that you can go in and check the bug there. Okay, so that is what the stack trace is for. It is very, very useful. And optionally, a cause. We can have causes for our exception as well. So how do we manage exceptions? Well, we have this mechanism called try catch. Try catch simply means that we have this block try where we can wrap the execution of the code that might potentially give us a crash. We wrap it with a try, and if an exception occurs, it will be handled in the catch block, in the corresponding catch block, okay? So we can see here that we are trying to convert, but we catch any number format exception that might occur. So let's try this out in code. So here, I'm going to surround my print line that can cause a crash with a try catch number format exception. Okay, so any number format exception will be caught here, and I can do something like print line an exception occurred. Now, importantly, only number format exceptions will be caught. Any other types of exceptions will not be caught, right? So let's go ahead and run this. Okay, and then we get an exception occurred, and that allowed us to continue the execution till the end where we have more execution here. So I mentioned that only number format exceptions are caught. You can also add another catch block, E of type exception, and this is the general exception. Okay, so here we can add a print line, a general exception occurred, and we can change this to a number format exception. So the reason why we have multiple catch blocks here is that if our code can generate multiple types of exceptions, then we can handle them independently, right? And it's actually a good practice to handle the specific exception in a specific way, okay? We might want to do something very particular if that exception occurred. However, if you have some generic way to handle all exceptions that might occur, then you can simply use this catch block, okay? General exceptions. Okay, so we try to run a block of code. If the exception occurs, the code and catch will be run. Okay, and then finally the execution can continue. Now, in this structure, try, catch, 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 we have another block available to us, and that is the finally block. The finally block will be executed whether or not an exception occurs. So whatever happens in try or in any of the catches, the finally block will be executed. Okay, so we can print line here, execution has completed. More code here. Okay, so whatever happens, whether or not we get an exception, we have execution has completed. Okay, so you can see here that a number format exception occurred, execution has completed, more code. One thing I forgot to mention is that if one of the catch blocks handles the exception, then the following blocks will not handle that exception, right? So in our case, our number format exception can fit in both these try-catch blocks, but it will only handle by the first one, which is this one. Okay, so basically, finally allows us to execute some code. And this is actually very useful in practice when, let's say, we are opening a buffer to try to read some information from a input stream, from the web, from wherever. We want to handle that buffer regardless of whether we get an exception or not. Otherwise, we will get some memory leaks and some problems in that area, right? So we want to be able to handle that no matter what happens, and the finally block will allow us to do that. Okay, so this is the structure finally, and it's a way to make sure that the required functionality is always done, is always performed. Okay, so that is the general structure for exceptions. One thing to mention here, I don't know if I should mention this right now because we haven't talked about functions in detail, but we will talk about them shortly. In any case, if you have multiple functions that call each other, let's say an exception occurred in one of the underlying functions and it is not handled there, then the exception will be propagated upwards through the chain of function calls to the top function, where if it's not handled, then it will crash our program. Okay, now this is kind of a topic that we haven't talked about, functions. So if you've never worked with functions before and you don't know what I'm talking about, that is fine. Don't worry about it. We will talk about functions shortly. If you work with functions in another development language, then you will understand how exceptions are propagated, and that works just as well in Kotlin. All right, so the last thing I wanted to mention here is the throw keyword. The throw keyword is basically a way to kind of generate and throw our own exceptions, okay? So here we have, for example, let's say at some point in my code, I decide that based on some parameters that, I don't like this execution and I just want to throw an exception. For instance, here, I want to throw an illegal state exception, okay? I don't like this input with an N. Okay, so whatever the message is, we have the option to throw whatever exception we want. An illegal state exception is a standard Kotlin exception where the program has reached a state that is incompatible with the current execution, right? So you will see this illegal state exception quite a lot in Android development. I'm not going to go into too much detail right now. Just know that the throw keyword is available for us to throw our exception whenever we want. Obviously, you wouldn't want to throw it for no reason, but if the execution does require it, then you have the option. And as I mentioned previously with the function exception propagation, if we are inside a function that can generate an exception, then it will be handled later on in up the chain of functionality. And especially useful, this is especially useful if we are developing, let's say, a third-party library that can be used in other applications. We require a way to be able to create some exceptions, okay, so that we propagate some error messages or some bad state up to the calling program. Okay, so that is how we would do that using the throw keyword. Okay, and that is the example. Right, so I think that is basically all I wanted to talk about. Try catch finally is going to be very useful in our development in Android, especially when we are working with resources that need to be handled and that take up a lot of memory, right? As I mentioned previously, the try can open up a whole host of objects that take up a lot of memory. And if we get an exception and our program just crashes, or we don't handle that correctly, then those objects will remain in memory and will take up a lot of space and can lead to memory leaks. And those are really, really hard to pinpoint. Okay, so very important, and especially finally is very important to be able to free up that memory and destroy our objects. Okay, we will talk about objects, by the way, later on in this course in a few sections time. All right, so that's it for this video. Thank you for watching. I will see you in the next one. Okay, so in this video, we're going to start to look at some composite variable types. Okay, so the composite variable types are basically types of variables that are made up of multiple primitive types. Okay, and the first one that we're going to look at is the list and array list. The reason I put these together is because they kind of rely on the same thing. So an array list is basically a list with some properties on top. Okay, so the main idea here is that they are composed of other more primitive types. And we have a few of these composite types or complex types. We have list, we have set, we have hash map, and a few others. So we're going to go through them one by one, starting with list. Now, a list is basically an ordered collection. It's basically the idea that you can put some primitive types together, okay, like numbers or characters or strings or whatever. You can put them together and treat them as a single unit, right? So that is the ordered collection. Ordered it is because it has an order, okay? So the order of the elements is important. Elements can be accessed by the position, so that's why the order is important. We can have a first element, second element, third element, and so on and so forth. Now, importantly here, indices always start with 0. So the first element in our list is going to be at position 0. Okay, so 0, 1, 2, 3, and so on. And then importantly, lists can contain duplicate elements. Okay, we will see some other collections that cannot contain duplicate elements, such as a set and hash map as well for the keys, but we will see that later on. But lists can contain the same element multiple times. So here is an example of a list of numbers. We have 1, 2, 3, 639, and so on, right? But we also can have multiple types in the same list, okay, in Kotlin. So here is a list with a integer and let's say a double, okay? So we can put those together in a list. And like I said, it can contain duplicates, so you can have, for example, the element 1 multiple times in the list. So to give you kind of a real world example, a list is basically similar to a sentence. So a sentence is basically a list of words. They have an order which is important, and we can repeat the same word multiple times. Okay, so when you think of list, you can think of a sentence. Now, some characteristics of lists. Here we can access the elements. Okay, so for example, let's say we have some months, January, February, March, and we can access the first one in the list is going to be index 0. Then we can access index 1 with .get. Okay, so either of these methods to access the elements is fine with these square brackets where we access the position, or with the function .get of 1. Now keep in mind here 1 is going to return us February because this is the position 0 and this is going to be the position 1. Okay, very important. Now, for months.get 3, if we don't have the element in our array, okay, so here we have 3 elements, but the positions are important, right? This is position 0, position 1, and position 2. So we do not have a position 3. So that means if we try to access that position 3, we will get an array index out of bounds exception. Okay, so you need to be very careful about that. Always check that you have that element before you access it. So I just want to create a new file here and try some of these things out. Lists.kt fun main. Okay, and here let's say we have val letters equals we're gonna have a list of, remove that. We will talk about what this symbol means. It is asking us for the type of elements that are contained in this list, but for now we're going to remove it because the type is automatically inferred when we actually add the elements. So let's say we have A, we have B, and we have C. Okay, we could have just as easily put months there, it doesn't really matter. But I just want to print line letters of 0. Okay, so one way to access an element is with these square brackets. And then I want to print line letters dot get. This is the second way to access the elements, and I'm going to give it the index 2. The index 2 is going to give me the C letter. Okay, so let's go ahead and run this. And I'm going to have A and C if everything works correctly. Okay, so we get A and C, so that's fine. If I try to access letters of 3, that is going to crash my program because there is no character at position 3. Okay, we just have position 0, 1, and 2. Okay, so we have our array index out of bounds exception. So make sure you don't access it in this way. Okay, so we can also iterate over elements. Basically, that means we take each element individually and we apply some functionality to it. But we will see this later on when we talk about for loops and things like that, right? So right now we don't have the tools to iterate over the elements, but just know that it is possible to go element by element and apply the same functionality to each element. And then we can get some properties, for instance, the size of the list and whether or not it is empty. And there are multiple things that we can get. So letters dot, and here you have all the functionality that we can access, right? So for example, we have our size here, but we also have index of a certain element, and this gives us the first index. So since remember, you can have multiple elements. So for example, if I say index of B, and let's say I add here another B, right? So here I will have 2 B's. Like I mentioned, we can have multiple elements of the same with the same value. But if we get index of B and I want to print line this index, okay, let me just run that, and that should give us the position 1. Okay, there we go. So it gives us the first index of with that value. And of course, like I mentioned, you have multiple functionality, multiple either functions that you can apply or properties that you can access. Okay, so let me just put index of B here. That's fine. Okay, so that is all for lists, but you can see here that I haven't mentioned how we can add an element to a list. Okay, so for example, I have my letters. I cannot do letters dot add D. Okay, that is not possible because this is a list, and a list is what we call immutable. So we cannot change the elements of a list. And that is actually quite an important thing that we want to be able to do, to change the list, to add, remove, and so on. So since list cannot do that, then we have another structure, which is called a mutable or changeable list. So a mutable changeable list, also called an array list, is basically a list that we can update the elements. Okay, so here, for example, we create an array list. Okay, we can add or remove elements. So we can add an element and we can remove an element. So here, if we go back to our list, we can say letters.add. Sorry, this is a list. So let's go ahead and create a new letters2 equals this time array list of, and we have A, B, and C. Okay, so letters2.add, this time we can add an element and we can have D. So if I print line the list now, letters2, then we should get A, B, C, and D. Okay, A, B, C, D. So that is fine. And then we can say letters2.remove, and we can remove the letter A, for example. And we can print line again, letters2. Okay, running that. And the second one is going to be B, C, and D, the second printout. B, C, and D, since we removed the letter A. Okay, so that is adding and removing, but we can also add and remove an entire collection. Okay, so here, for example, we have some more colors, and we just add all of them to it. So here, I can actually, even though they kind of contain the same information, I can say letters2.add all from letters. Okay, so I can add all these letters to my array list. Okay, so if I print line and I say letters2, okay, I'm going to run that and we get a longer list, which will contain duplicate elements, of course, B, C, D, and you can see at the end, it added A, B, C, D from the letters list. Okay, so you have all these elements now in your array list and you can play around with them. And of course, for array lists, you have more options when it comes to functionality. Okay, so letters2 dot, and you can add or you can access more functionality here. You can of course access the elements in the same way as we did for letters. So letters of 0 and dot get. Okay, usually you would use this kind of access, not the dot get. That's a bit more verbose, and this is more shorthand, but you can also use it. In any case, you can try out a lot more functionality here to play around with the elements of your list. Right? You can see here that we have kind of a weird structure. Maybe you haven't seen this before, but we will talk about this structure later on as well. Okay, this kind of relates to anonymous functions, lambdas, and so on. Okay, so we will talk about that. So yeah, just go ahead and play around and have a look through the functionality that you can access for both list and array lists to kind of give you a kind of clearer understanding of what you can do with both. Okay, so as we can add all from a collection, we can remove all from a collection. Okay, so the opposite functionality is also available. Right, so that is all I wanted to say now for array list. We will talk about them more later on when we actually talk about for loops, where we can actually go through each element of a list, or in general of a collection, and apply some functionality to it. For example, let's imagine we have a list of users in our website, and we want to go through all our users and send a personalized email with their name and some special offer that we want to give, right? So we want to be able to go through each element and apply some functionality, and we will see how we can do that when we talk about loops. But for now, it's important to have a view of what array list does. That is all for list and array list, and we will continue on with our collections in the next video, where I think we will talk about sets. Okay, so I will see you there. All right, so in this video, we will talk about sets and hash set. Okay, so we've talked about list. Now, a set is slightly different from a list. It's kind of the same concept where you have multiple primitive types that are kind of bundled up in a single element that we call a set. However, as opposed to a list, the set will store unique elements. So a list, we know that it can contain the same element multiple times. In a set, even if you define the set as having the same element multiple times, it will only be stored once. So here is an example. We have a set of these numbers, 6, 34, 6 again, and 42. And then if we print them, we can see that 6 appears only one time. So it stores unique elements, okay? That's the main thing. But also, it stores them in an undefined order. So the order of the elements is not important for a set, okay? You can think about, for example, a deck of cards, okay? When you're playing with a deck of cards, that is a set of cards. You have unique elements, but the order is not really important, it's not relevant, right? So that is what a set is. If we create an empty set, we must specify the type. So here, for example, we have our set of integers that is empty, okay? It's the same thing that we do for the list. If we have an empty list, we need to provide the type. If we have an empty set, we need to provide the type as well. Okay, so let's go ahead and try it out. I like it when we actually do, we actually write the code in our editor, set.kt, because that allows us to kind of, memorize it and internalize it better and more easily. Okay, so I'm gonna have, let's say, numbers equals set of, and here I can say, okay, sorry, let me just give it a val. I can either give it an integer type and just leave it at that, and then print line numbers here. Okay, and if I do that, that should print out an empty set. We have it here. Or I can just remove the type and let it be worked out by the system, and I can give some numbers here and 2. And you can see that 2 appears twice. So let me just run that and print it out. And in the printout, 2 should appear only once. Okay, so there we go. Also, the order is not really important. Okay, here we have the same order because we've just defined it here and there's no functionality applied to it. But in reality, the system doesn't have an order in which it stores the elements. All right, so we have an empty set. We specify the type. Importantly, a set can contain a null element, but again, only a single one, since we cannot have duplicate elements. Okay, so we can have null here. That is fine. We just need to know that it will only appear once. Now, again, for set, we cannot add or remove elements. Okay, so once we create the set, it is set in stone and we cannot change it. Okay, so if we do need to change that functionality, that set of numbers, we need to have a hash set. A hash set is basically a mutable set. It's the same idea that we have with list and array list. Here we have set and hash set. So here we have a mutable set where we can actually add or remove elements. So here we add an element and then we can also remove it, obviously, and then we can add a whole other set, similarly to how we've seen for the list and array list. So here, for example, I can say if instead of set of, I have hash set of, okay, no type provided, and I say numbers dot add, and I can add some elements. Okay, so I can add the element 8. Okay, and also I can remove some elements. So numbers dot remove, let's say I remove the element 2, print line numbers. Okay, so that should give me a new set with 8 and without the element 2. Remember, even if 2 appears twice in the actual set, it is only once. So once we remove it, it is gone. Okay, so these are the elements. Okay, so that is fine. And you can see that here that the order is not preserved, right? So we have removed the 2 and we have 4, 5, 6, 9. But here we have 4, 5, 6, 8, 9. So the 8 was not added at the end. It was just added anywhere, wherever the memory was defined or however it is stored internally. But also for sets, we have a few other functions in addition to just adding and removing elements. Okay, so here we might have numbers dot. We have dot size, which is a property. Okay, it will give us the size of the set. But we also have all these functions that we can apply to our set. Okay, so go ahead and play around with these if you like to kind of get an idea. Don't worry too much about remembering any of these. When you will encounter the requirement in your application or your code, you will kind of search for that requirement, for that functionality, and you might find it here. Okay, whenever you're this is kind of a general basic principle. Whenever you are faced with a problem, always check to see if that problem was solved by default by the language, okay? Because it will be much more efficient rather than implementing your own solution, okay? So if it's something fundamental, such as, let's say, applying some functionality to all elements in your collection, you have .map, for example. This one will allow you to apply this transformation, this functionality to all the elements in your set. And in actuality, map is quite useful and quite common, and we will actually have a video on this particular functionality, .map and a few others that are very common. But my point here is that you will find, just by looking through this list, you will find some functionality that might be useful later on when you are actually trying to develop a real-world application. In any case, we're going to stop here for the set and the hash set. I just wanted to introduce the concept, and it might come up later when we talk about flow control in our applications. Okay, so don't worry too much about this. In reality, I think list is a bit more commonly used than set, but obviously set has some very useful use cases as well, and it's important to know that it is there. All right, in any case, we're going to move on to our next and final collection, which is the map. Okay, we will see that in the next video. All right, so in this video, we will talk about the final collection that we will cover in this course, and that is the map. Now, the map is basically a set of key value pairs. Importantly here, there are two collections inside the map. There's the collection of keys and there's the collection of values. And one key will point to one value, okay? Now here, keys are unique. So the keys are actually a set. Okay, so very important. They are a set, they are unique, and they are not stored in any order in memory. Okay, so you cannot get the first key, second key, third key, and so on, right? They are a set basically. However, the values can be duplicate. The values actually don't really care. They are neither a set nor a list, okay, since we do not have an order for the values. In order to get a value, you have to access it through the key. Okay, so we have a key that points to a value. And the way we create a map is very simple. We have a function called map_of, and we map one key to one value. In this example, I map numbers to strings. Okay, so 1 with the keyword 2, and 1, 2 to 2, 3 to 3, and so on and so forth. That is one way of creating the map. Before I show you the second way that we have available, let's go to our editor and let's go ahead and create an example here, map.kt. We have our main function. Now I'm going to have val let's say count equals map of. Again, you have to specify, if you're going to have an empty map, you have to specify the type. However, here you have to specify both the type for the key and the value. Okay, so you could put int and string, okay, and leave it at that. Or you could let the system infer the type, and you can just simply say 1 to 1, 2 to 2, and so on. 3 to 3. You can have an example for instance here, translation equals map of, let's say we're translating from English, 1 to, let's say we're translating to French, 1 for 1, and 2 to 2. Okay, whatever the translation is. This is another kind of example of what you can use a map for. And if we go ahead and print line, let's say we print line translation. I'm going to run that. Let me just add another element here. 3 to 3. Okay, and let me run that again so that I get the third element as well. 1, 2, and 3. Okay, so that is one way to create the map. Another one is to use this pair functionality here. This is actually a class which we will study later on, but I just wanted to include this in case you wanted another way to create the map. However, I think this is a bit more verbose. It's usually easier to just use this method of creating the map. Okay, and if we print it out, we're going to get 1, 2, and 3. And as I mentioned, if we create an empty map, we must specify both the key and the value types. Okay, so int and string. Okay, so that's the main idea behind a map. Now, how do you access elements? Well, basically, you get a value based on a key. So here, if we try to get the key 2, that will give us the value of 2. Okay, we're not accessing the position for a map, we're accessing the key. Okay, so here, if I try to print line, let's say translation of, let's say 2, translation dot get of 2. Okay, and if I run this, I'm going to get the value associated with this key, which is going to be the French translation. Okay. You can also get the whole set of keys and also the set of the collection of values. Okay. So the keys are a set. The values are a simple basic collection. There's no ordering or anything like that. Okay. So if we go ahead and just print out print line, translation dot keys. Okay. Then we're going to get the keys 1, 2, and 3. Okay, 1, 2, and 3. I forgot to add it to the slides, but here you can also access the key with this access with the straight brackets. Okay, translation of 1, let's say, and that's going to give us the value for the 1 key. Okay, very similar to, there it is, very similar to how we access the list, okay, the position in the list. Okay, now similarly to how we have the array list and the hash set, we also have a changeable or mutable map variant, right? And in this case, we call it hash map. Now, a hash map is a mutable map, whereas with a map, you cannot just add and remove elements. With a hash map, that is possible. So here we have an example. We have a hash map instead of a map, and we can add, for example, a key value pair. Okay, so we can put our 4th element here. So let's go ahead and try it out. Here, let me just remove this. And I'm just going to add it at the end here. And instead of map, I'm going to make it a hash map. Okay, so I have 1, 2, 3. Now I want to add, or in this case, the method is put. I want to put a key and a value. So I'm going to put 4, comma, and 4. Okay, so here if I go ahead and print line my count hash map, I'm going to run this and I'm going to get 1, 2, 3, and 4. Okay, 1, 2, 3, and 4. So this is a mutable map or a hash map. We can change that functionality, that collection. And we can also do a few other things. So for example, I put here, we can remove an element, we can replace a value, and we can remove all elements from a hash map. So let's go ahead and try a few of these out. So I'm going to say count dot, let's say replace. I'm going to replace 2 with 22. And I'm going to print line my count. And then for some reason, I want to remove or clear to remove all the elements. And I'm going to print line my count again. Okay, so running this, it is pretty obvious what it will do. It will simply print out a map with 22 instead of 2. Okay, there we go, 22. And then it will simply clear the map. Okay, so we have an empty map here. And of course, again, for the map as well, you have all the functionality here. Okay, you can simply get the keys, the values. You can get a value for a particular key. You can do a whole host of things here. You can check if it's empty or not, and so on and so forth. Okay, so again, for map as well, you can play around with these and kind of get an idea of what they are. A lot of these will kind of be similar to our collection, so to our other collection. So count.isEmpty, for example, will be available for pretty much any collection that you have, whether it's a list, a set, or a map, or the mutable versions of them. It will be available there. Okay, right, so that's it for the map and the hash map, and I think that's it for the collections. And then we will move on to control flow in our applications. Okay, so things like if statements and loops. Okay, cool, that's it for this video. I will see you in the next one. Okay, so in this video, we're going to move on to flow control, and we're going to talk about the if statement. But before we talk about the if statement, let's have a look at what flow control is. Flow control is basically the ability to change the direction of execution of a program. Okay, it allows us to make decisions based on some criteria that we decide. And based on that criteria, we can say we do a block of code, we execute a block of code, or we decide to execute something else. It also allows us to execute the same code multiple times with different criteria, okay, with different variables that can change and so on. We will see that later on. For now, we will focus on the first part, changing the direction of execution of a program. And that is done with the if statement that we will see in this video. Like I said, allows us to run parts of the code multiple times. That is done with loops. And it allows us to stop execution of a part of code when we reach some point, okay? When we reach some condition that dictates that we should stop that execution. Okay, so that is kind of a general overview of flow control, but you will get a better understanding of what it is when we talk about the ways we have to change that flow. So first of all, we're going to talk about the if statement. Now, the if statement is very simple in its concept. Basically, the program execution arrives at an if statement. It checks whether or not a logical expression is true or false. If it is true, it does something. If it is false, then it does something else. So the way that looks in code is basically if logical expression, we have a block of code here surrounded by curly brackets where we do something. And then we have a keyword else. Okay, so the second branch here, we do something else. So based on this expression, we decide to split the flow into two. Now, importantly here, the else is optional, right? So we could have an if statement where an expression is true, we do something, but if it's false, we don't do anything. So that is perfectly fine, and that is a quite common use case as well. So let's go into our editor, and I'm going to create a new file called if statement. Let's say .kt fun main. Okay, so here let's put in place an if condition, right? So we're going to define a variable, let's say night equals true, and we're going to say if night, then we're going to print line. Let's say we want to brush our teeth, brush teeth, and then we also want to sleep. Okay, and we have an else if it's not night. So if this is going to be false, then print line something like be active. Okay, so what do you think will happen if we run this code? Well, basically, the execution will arrive at this stage. It will say, is night true? In our case, it is. Then we execute only this block of code. If night would be false, then we execute this block of code, and then we have finish execution. Okay, so let's go ahead and run this. All right, it should finish in a second. Okay, so we have night equals true, so that means we brush teeth and sleep, and then finish execution, right? The print be active is not run. If we have here false, then if we run this, we're gonna skip this part because night is false, and we're just gonna print out the be active and finish execution. Okay, so that is basically flow control. It allows us to switch between two blocks of code. Okay, now brackets can be omitted if we only have one expression. So that is quite, it's a shorthand. Basically, we can remove the brackets for else, and it will still work fine. In our particular case, we cannot remove the brackets for the positive branch because we have two expressions here. And actually, I've put two expressions on purpose so that I can show you that brackets cannot be removed here. Okay, if we remove the brackets here, we will get an error for the else. Okay, expecting an element. All right, so let's go back. So we can remove the brackets if we have one expression. Here inside the block of code, you can have anything you like. You can have function calls, you can have as much functionality as you like, and including other if statements. So for example, here I could say if, say sleepy, then sleep, or I don't even need the brackets here. Right, so if I define a variable sleepy equals true, then, and this is going to be true because it's night, then I'm also going to sleep. Okay, but if I am not sleepy, then this will not be printed. Okay, brush teeth and sleep. But if this is false, and if I execute this, I will brush my teeth since it's night, but I will not sleep because I am not sleepy, right? So just brush teeth and execution. All right, so you can have more if statements. We also have a shorthand if statement that is very useful when we only have one expression for both true and false. Okay, so here I could say something like if night, let me just comment this out, and I'm gonna put the finish execution at the end as it should be. Okay, that doesn't seem to work. Let me cut and paste. Right, so yeah, that's why it didn't work, because I didn't complete my if statement. So if night, I'm gonna print line brush teeth and sleep, else on the same line, print line be active. So that is basically, let me put that back, that is basically the shorthand if statement. I can put everything in a single line without curly brackets because there is only one expression for both the positive and negative, right? If that wasn't the case, I cannot use the shorthand if statement. So here, my night is true, so I'm gonna brush teeth and sleep. Let's go ahead and run that. As you might expect, we get the brush teeth and sleep. So that is fine. Shorthand if statement. And an if statement can return a value. Okay, so here I have my example. Let's go ahead actually and put it in code. So val number equals 25. If or val is even equals if statement. Now, if number remainder of 2 is gonna be double equals to 0, then number is even, else number is even odd. Okay, and we can print line is even. Okay, so is even for number 25 is going to be number is odd. Okay, and that's because we set the number here, but if the number comes from a function result or from a third-party library, whatever it is, then this if statement kind of makes sense. The value, the expression here, returning a value can work also for a regular if statement with all the curly brackets and everything, okay? This is just a shorthand because we have just two simple decisions to make, but you can also add it to this kind of if statement with all the brackets and functionality. Okay, like I mentioned here, we have these two examples. Right, so that is the basics of the if statement. It's quite simple, quite easy to understand, and of course you will use it pretty much constantly in your code and in your applications. Okay, so you will kind of internalize it quite quickly. One more thing to mention about the if statement, I kind of mentioned this previously, that inside an if branch, you can have other if statements, and also that if you have only one statement, you can remove the curly brackets. So that means if you only have one statement inside an if branch, and that statement is another if statement, then that will lead to your if having multiple branches. Okay, so the general structure for multiple branches is something like this. If expression A, then do something else. If expression B, then do something else. Else if expression C, as many expressions as you like, and then a final else statement. Okay, so this is kind of implied from what I said previously, but it's important to kind of clarify it and have it written in clear here, since sometimes we also use this expression. Okay, although in this case we have another expression that is more appropriate, but we will focus on that a bit later on. But for now, that is the general structure of multiple branches if statements. All right, so in this video, we're going to talk about the when conditional. Now, the when conditional is very similar to the if conditional, except that the when deals with arithmetic operations and their results rather than logical operations. So the main idea is this. So we have a when conditional, we have a variable or expression, and we have a number of results for that expression. So when the expression is of value 1, then do something. When it is value 2, do something, and so on. We also have a default branch. If we don't fit into any of these categories, then we have the option to provide some default functionality for our block. Okay, so very simple, similar to if, but for expressions and variables, right? So here is the structure in pseudocode, or rather actual code. So here we have our variable. This could be an expression. and we have value 1, then we do something in this block of code. We have value 2, value n, however many values you would want to add here, it is perfectly fine. And then by default, for the else, we then do something by default. Okay, so that is the general structure. Let's go to our code and implement a example. So when conditional dot kt fun main. Okay, so what can we do in this when conditional? So let's say we have a parameter, a variable animal is going to be, let's say, cat. Now we also have a variable action is going to be, let's say, of type string. Okay, we haven't initialized it. Now keep in mind, this is a val and this is a var. The var is because we want to be able to update it. So we can say when animal. Okay, here we have curly braces and we give it a value. So cat. So if the animal is a cat, what can we do? Well, we can, let's say, action equals pet it. Okay, let's say we have a dog and arrow symbol, curly bracket, action is going to be, let's say, feed it. Okay, and we have an else. By default, we don't know what to do, so we can say action equals Google it. Okay, so basically this means that we will get the action based on what the value of the animal variable is. Okay, so in our case, since animal is always cat, then the action is always going to be petted, but you get the idea. And then finally, if we print line our action and we run, it is going to be cat. So we fall into this category, then we will get to pet it. Okay, as soon as this finishes running. Okay, so we get petted. And if this is a crocodile, or the system doesn't really know what to do, so it just tells us to Google it. Okay, so that looks pretty good. Now, we have a few things to mention here. First of all, curly brackets or braces are not necessary for a single line of code. So in our case, of course, inside this block of code, we can put as many instructions as we want. But since we only have one, then we can remove these curly braces. Okay, so that is perfectly fine. We can do that for the others as well, since we only have one line of code every single time. Okay, so that is, it looks a bit nicer, doesn't it? Without all the curly brackets. And that runs just as fine, just as well as it did before. Okay, this is running a bit slow, but there we go, we get Google it. Now, apart from that, we also can return a value, okay? So we can get a value from our when. So for that, I want to add another when block. And I'm going to say here val month is going to be, let's say, January. And I want to get the number of days for my month. So val days is going to be when. And inside the when I have month. And here we can have a small algorithm to give us the number of days for the particular month. So if the month is, I think it's April, that's going to give us 30. April is the first month with 30. If it's February, that's going to give us 28. We're going to simplify and say this is a non-leap year. And then else is going to be 31. Now, this doesn't include all months. We will update it shortly to include all the months, but for now, we only have January, which should give us 31. And if I print line days, it's going to give me the correct result for January, right? For other months, it might not be correct, but for January, at least I know it's correct. So here we have the days variable that is updated with the result from this when block. So let's run this. And I haven't finished building this because we will finish building it shortly. But for now, January has 31 days, which is correct. Okay, so we can return a value from the when block by simply providing the value here as the result. Or if we have a block of code like this, then if we want to provide a value, we have to put it on the final line of that block of code. Okay, we can have as many instructions as we like here, do something. But then if the final line is a value, then that is returned to the variable in question, right? So we can return a value, and if two values have the same effect, they can be put on the same line, separated by a comma. And this is why I haven't yet completed this block, because actually, since multiple months have the same number of days, we can simply add them here. So we can have April, we can have, I think June has 30 days, then September, October 31, and November. Okay, so these four have 30 days. February, in our case, non-leap year, has 28, and every other month has 31. Okay, so here, if we have October, let's say, we're going to get our 31 days. Okay, now, obviously, whatever we put here, if we put crocodile here, it would have 31 days. So this is not really perfectly well designed, but it illustrates the point that we can put multiple values here separated by comma to have the same effect, same result. And I think that is all I wanted to say for the when block. That is all. So we have the if block, we have the when block, and I think in the next video we're going to start to look at some loops and starting with the for loop. So I will see you there. Now, one of the most common flow control structures is the for loop, and this is used constantly in applications, similarly to the if block, and to some extent the when block as well. Now, for loops are very useful because they allow us to kind of loop through a number or a collection of elements and then apply some functionality for those elements, right? So this is how it works. Basically, we have some sort of collection here. We go through each element. We take one element from the collection. We do something for that element, and then we move on to the next element of the collection. Okay, now importantly here, the collection should not change while we are looping through that collection, right? Because if it changes, then it could cause some crashes, some problems. But normally, since we have lists, since we have sets, those do not change at all while we loop through them, so that works fine. Okay, now basically, at its most fundamental, a for loop executes a block of code for each element in an iterator. Now, what is an iterator? An iterator is simply a construct that iterates through some collection. Okay, and we have two types of iterators. We have the collection iterator and the range iterator. The range iterator simply goes from, in this example, from 1 to 10. Okay, so that iterator will have the value 1, then value 2, then value 3, all the way up to 10. Okay, so this is how the for loop looks in code. We have some collection. We say for item colon string if you want to provide a type, but that is not necessary. That is optional. So we can say item in collection. And then we do something, okay? So let's go ahead and put this in code so we can better understand it. So here I have a new file, for loop.kt fun main. Okay, so let's create a collection first. So val animals equals list of, okay, and let's have some animals. Let's say we have a cat, we have a dog, we have a mouse, and we have a bear. Okay, so what we want to do is we want to feed all these animals. So the way we do it is we loop through this collection. So for animal in animals, Okay, now here we have our parameter animal that is going to take the cat value, the dog value, and so on through the whole collection. Okay, so we can use this variable in our block. So we can say print line feeding the $animal. Okay, so if we run this, then the loop is going to go through the whole collection and it's going to print out feeding each animal separately. Okay, so let's have a look. Feeding the cat, feeding the dog, feeding the mouse, and the bear. Okay, so it kind of makes sense, right? So we have a collection, we go through each element and we apply some functionality to that element. But we're not limited to collections. We also have the option to use ranges. Okay, so in this case, it's very similar actually. We have for I in this particular range, and we do something with I. So let's try that here as well. Let's say for I in 1.3. By the way, the name of the variable here is totally optional. You can give it whatever name you like, whatever variable name you prefer. And here I can say print line strike $I, and after the for I can print line your out. Okay, let's assume this is baseball, right? So we have strike 1, strike 2, strike 3, and then you're out. Okay. I put $1 instead of $I. My mistake. Let's run that again. Okay, it is running. Strike 1, 2, 3, you're out. Okay, so that is the example. So we have looping through a collection or looping through a range. Now let's have a look at ranges in a bit more detail. So we have a few different options. They can be ascending, as we've seen, 1 to 10. They can be descending, so 10 to 1 if we want. In this example, 10 down to 0, okay, including the 0. And then it can skip steps as well. So 10 down to 0, step 3, it will take, it will skip 3 every time it moves on to the next element. Okay, so let's have an example of that as well. Here I'm going to say for I in 10 down to 0. Okay. Now I'm going to print line I. One more thing I wanted to mention, the variable that you define here is only valid for the for loop. Okay, so you cannot use it outside. And this is the reason why I define the same variable I here and I here. And I is actually quite a common variable name in for loops by convention. Okay, you don't have to have I, but by convention you have I, J, and so on if you need multiple. But the first one is often I. I'm not exactly sure why. Maybe it stands for iterator. I don't know, but it is a convention nonetheless, right? So here we have I in 10 down to 0. Let's put a step 3. And then we're just going to print line I. Let's run this, and then we will see the elements that it goes through. Okay, so we have 10, okay, because we're starting at 10. Then -3 is 7, -3 is 4, -3 is 1, but -3 is -2, so it will stop at 0, right? So it won't print out anything after that. So these are the ranges for the for loop. Also, what I wanted to mention is that inside a for loop, you can have any code you like, including other for loops, including if statements or when statements or whatever. Basically, any code will do just fine. And to show you an example of two for loops, one inside another, I want to print out a matrix here. Okay, I can show you a standard way to print out a matrix using two for loops. So the way we do that is we can say for I in a range from 1 to 5. Okay, 1 to 5 is pretty arbitrary to be honest, but it will give us a matrix of 5 by 5. And then inside this for loop, we're going to have a for j. Now this is j. I cannot use the same variable here because I am inside this for loop. So I, the variable named I, will be valid inside this for loop as well, right? So I need to use another variable name, and I'm going to go with j. By convention, we usually go alphabetically, starting from I. So I, j, k, l, whatever variable you want to give it. So here I have for j in also 1 to 5. Okay, and here I'm going to simply print line, and I have a string with a $I, comma, space $j. And here I'm going to put a /t for a tab. Okay, so I have a little spacing there. And then outside the inner for loop, but still inside the main for loop, I'm going to have a print line. And I'm going to leave this empty. I want just a new line here. One mistake I made here, inside the second for loop, I just want a print, not a print line. Okay, so all these are going to be on the same line. Okay, so that's it for our matrix. So let's go ahead and run this. And if everything works well, then we should see, there we go. So we see our matrix with position 1 and 1, 1 and 2, 1 and 3, and so on. This kind of isn't ideal for me as a developer because the position starts at 1. So I would rather it starts at 0 and 0, right? That looks more natural to me as a developer. So let's go ahead and run this. We're going to have 6 by 6 this time, since we'll go from 0 to 5. Both are included, but that is fine. So we're going to have 0, 0, 0, 1, and so on until 0, 5, and then move to a new line and run that inner loop again and again 6 times. Okay, so that is how we would print out a matrix of, in our case, 6 by 6. All right, so I think that is all for the for loop. Again, we will use it quite a lot throughout our whole development. So it will be quite easy to get used to it and pick it up as you go along if you've never used it before. If you've used it in other software development languages, then it's pretty similar pretty much anywhere, isn't it? So you might already have a good understanding of what it does. It's just a bit of syntactic sugar how you use it in Kotlin compared to other languages, but it's basically the same at its foundation. All right, so that's it for this video. Thank you for watching. I will see you in the next one. Okay, so now we're going to talk about the final flow control element, which is the while loop. Now, the while loop is very similar to the for loop in the sense that we evaluate some expression and do something as long as that expression is true. Okay, so as the execution arrives here, we go through this loop as long as this expression is true, and when it is no longer true, then we can exit. Okay, one important thing to mention here is that make sure when you're using a while loop, make sure this expression is eventually going to be false. Otherwise, you will be stuck here in an infinite loop. Okay, and that will basically crash your execution. Right, so it executes a block of code while a condition is true. So it's something like this: while a expression, I smaller than 10 in this example, we do something, and we need to make sure that we kind of manually increase this I, okay? Because otherwise, like I mentioned, we will be stuck in an infinite loop since the I variable never changes. But as long as this expression will eventually be falsified, then this is fine. Okay, so let's have a look at an example how we might do this in code. So while loop.kt fun main. Okay, so let's say I have an example here. Let's say we have a puzzle, okay, a kind of a cardboard puzzle where we have 20 pieces and we want to place those pieces one by one on the puzzle, right? So when we're placing a piece, we're going to simply print out a message. and we need to make sure that we have exactly the number of pieces that we require, right? So I'm going to say var puzzle pieces equals, let's say 20, and var current, let's say pieces placed, okay, equals 0. So we're going to count how many pieces are placed, and we're going to say while pieces placed smaller than puzzle pieces, okay, because remember it starts at 0, so the smaller than is strict, is not smaller than or equal to. Okay, so we have a block of code here, and we're going to say print line piece dollar pieces placed. Okay, so we're placing a piece, we're printing out a message, and we're incrementing our pieces placed, right? So pieces placed plus plus. Okay, so this loop will go through all the elements until pieces placed will be 20, at which point this will no longer be true, and we can exit the program, and we can simply print line finished. Okay, so let's execute this and see what we get. So normally we should get about 20 of these messages, and then finally the finished message here. Okay, let's have a look. So there we go. We have piece 0, 1, 2, 3, and so on until 19. We don't go up to 20 because once we reach 20 here, we're going to go through the loop again, and the condition is no longer satisfied. So we kind of get out of the loop and go to finished, right? So we have 19, and of course, since we start from 0, then that means we have 20 pieces placed. Right, so that is the while loop, and we also have another variation of the while loop, which is the do while loop. It's very similar to a while loop, except that the condition is evaluated at the end. So you can see here that we evaluate the condition first, and then we move into our code execution, whereas for the do while loop, we do it the other way around. First, we execute something, and then we evaluate the condition, right? So we have do something while a expression is true. Okay, so let's try that out. Let me just comment this out. We can change this loop very easily to move to a do while loop. So let me just copy it first, copy. And then I'm going to print it here. So instead of a while something here, we have do some execution while pieces placed smaller than puzzle pieces. Okay, so we've moved the expression at the end rather than at the beginning. But of course, we need to have a keyword here to let the system know what we want to do. So do something while pieces placed. Okay, let's try it out. It should print out pretty much the exact same message. We have all the pieces and then a finished, right? So we get that exact output, except here the condition is at the end. Those are often exactly the same. There are situations in which you want to perform something for the first time, even though, or rather to check the condition at the end, right? But at least have one run through your code. Those are kind of edge cases, and that's when we might use the do while loop, but most often we use the while loop. That is the most common. And of course, as with other flow control blocks, a while loop block of code can contain anything, including our other loops. So you can have other while loops inside, you can have for loops, you can have if statement, whatever you like, whatever you need for that code. All right, so that's it. I think we have finished our flow control elements, right? We have the if, we have the when, we have the for, and we have the while. And those are the four main elements of flow control. I think that's pretty much it. And then in the next few videos, we can move on to kind of a bit of higher level stuff. Okay, that's it for this video. Thank you for watching. I will see you in the next one. Before we move on to other concepts, I want to talk about two keywords that we have available in our loops and in our flow control, in our loops mainly. And those keywords are break and continue. Now, break basically will terminate a loop, okay? If you want to abruptly stop a loop for whatever reason, you can use the break keyword. And usually we have some check, some condition that basically checks each element in a loop to see if you can continue the processing. So break is kind of a very harsh way to stop a loop because it will not continue through the whole list of elements, right? Whenever it encounters some situation where a condition fails, then the loop will be broken and the rest of the elements in that collection or range will not be processed. Okay, so let's have a look in code to see how this works. So basically let me just create a new file here, break and continue .kt fun main. Okay, so let's say we have a list. We have val only even numbers. That's the list name. And we have a list of, and let's say we have 2, 8, 4. Let's add 7. Okay, this is an odd number and that will give us a breaking condition. Let's say 6 and 9. Okay, and we're going to loop through these numbers. So number in only even numbers. And what we want to do is we want to divide that and print out what the half of each number is. So here we're going to print line half of dollar number is dollar expression number divided by 2. Okay, so half of numbers is number divided by 2. But I want integers here, so that means I need to check if the number itself is odd. So if number %2 is not equal to 0, then I'm going to break my loop. So if I get a number that is not even in this only even numbers collection, then I will break. But if not, I will continue and print out everything, right? So what do you think will happen when I run this code? Basically, it will go through the list. 2 is even, 8 is even, 4 is even, but 7 is not even. So that means this condition will be fulfilled and then my loop will break. And that means 6 will not be printed. Okay, so let's go ahead and run this code. So it will skip 6 and of course it will skip 9. Okay, there we go. So half of 2 is 1, half of 8 is 4, half of 4 is 2. But then when it encounters this, it will simply break. Okay, so the rest of the elements here will not be processed. So that is the break. Break basically immediately stops a loop and then goes out of the loop and continues on with the execution. Now, it won't crash your program, obviously. It will simply move the execution out of that loop and it will continue. So print line here, continue execution. If I run that, when the break is reached, it will simply go out of the loop and then continue the execution. There we go. So that is the break keyword, but we also have kind of a milder keyword here, which is continue. It will not kill your loop. It will not stop your loop. It will simply proceed to the next step of the loop. Okay, it will skip the current step. As soon as the keyword is reached, it will skip the current step and it will proceed to the new one. Okay, so how does this work? Well, here I will just comment out this code. I'm going to say if same condition, number %2 is not equal to 0, then continue. Okay, so in this case, what will happen? When it reaches this 7, it will see that this condition is filled, so it will do continue, but it will continue in the loop. It will just skip to the next step, and the next number is going to be 6, and that is working out fine. Okay, so it will actually go through the whole loop until the end. It will simply skip the steps that are not interesting to us. Okay, so let's run this. And then the output should be same as this, but with the 6 here as well. There we go. So it is basically up to you and up to what makes sense in your current code, in your current application, which one you use. Do you want to completely stop the loop, even though some of the elements have already been processed, or do you want to simply skip one element and continue on with the processing of other elements? It is basically a design decision, but it's important to know that both options are available. So we have reached the last major topic of the kind of foundations of Kotlin development, and that is functions. And I've left functions for the end because we will kind of use concepts that we've studied so far in our functions development. Okay, so it's not particularly complicated, but there are a lot of details to functions. Some of them are common throughout basically all software development languages. Some of them are particular to Kotlin. And in the following, I think, 3 lectures, we will go through them one by one, and we will see how they kind of work together and relate to each other. So functions. Now, we've already seen functions quite a lot so far, but in this video, I will kind of go from, let's say, complete basics. Even though we've already seen what functions are, so basically whenever we write code, we already have a function here and we already invoke functions, for example, print line. But we're going to skip all that and we're going to go from the complete basics, from 0 to kind of try to understand functions completely. So what are functions? Basically, a function is a way to group code that can be executed in your code and in your application. You can define a function that will be executed 0 times, right? So you have the right to pretty much write any function even if it will not be executed, but you can invoke a function as many times as you like. So I've put here 0 or more times. Now, importantly, you may not get the same result on different runs, and that is because functions can do pretty much anything, so they can change variables in your application that they rely on to give you your result, but also they take input parameters, and based on those input parameters, the output might be different. Can accept input and return output. And to create a function, basically we have the keyword fun. We provide the function name. We have parentheses. Inside these parentheses, we will define the parameters that go into our function. And then we have a block of code separated by curly brackets or braces, right? So inside here, as we're used to already, we can do pretty much anything we like as long as it is valid Kotlin code. Okay, so this is how we define a function. And then to call and invoke a function, we simply provide the function name, and inside parentheses, we pass whatever parameters we need to pass. In this small example, we don't have any parameters, so we do not pass any parameters on the function call. So let's go ahead and try this out in our code. I'm going to create a new file here, functions.kt. I'm going to create my main function, but down below, so after the closing bracket of the main function, afterwards we're going to define our own function. I'm going to say fun, say hello, no parameters, okay, no input parameters, and here I'm just going to say print line, and I'm just going to say hello everyone. Okay, so hello everyone. Now this is my function. At the moment it is not invoked. Nobody is calling this function. So what I would like to do is I would like to call this function a number of times, right? So for that, I'm just going to create a for loop here. For I in, let's say, a range of 1 to 5. And I'm just going to have say hello inside this for loop. Okay, so let's go ahead and run this. And basically we are calling this function 5 times, right? It's gonna be the same output every single time because we don't have anything that changes inside the function. But here we simply have hello everyone printed out 5 times. So that is the absolute basics that a function can do. It can simply execute a block of code a number of times, right? Now, a function can accept parameters, right? So here we have an example. Let's say we want to print out a double of a certain number, and we have that number as an input parameter, and we can call this function with a parameter here. Now, the parameter type that we pass here must be the one that we define in our function, okay? The way we define a parameter is we have number or parameter name, colon, and type. Okay, so here, let's go ahead and implement this. Fun double. And here we have a number of type integer. Okay, and the functionality of this double function is going to be simply to print out a message double of $number is, and we have an expression here, number multiplied by number, or rather multiplied by 2 is just the double. You could do a square and have number times number, but we're going to keep it at that. And then here we're going to call double of 5, and that should print out just 10. Okay, 10. Double of 5 is 10. Now you could have multiple parameters here that in that case they need to be separated by a comma. So let's say we're going to create a new function, fun multiply. Now, of course, we already have a multiply function in our Kotlin, but let's just create a function here, a of type int and b of type int. Okay, so if we define 2 parameters, then they are separated by a comma, and then here we will simply print line a times b. Okay, this needs to be an expression inside of a string. Okay, so a times b, and if we call here multiply, we need to pass our parameters separated by comma. So 3 and 8, that's gonna give us 24. There we go. So we have 24. So that is the way we define our parameters. The type here can be anything, not necessarily just int. It can be anything you like as a type. It can be primitive types. It can be collections, basically anything you like. All right. So that is the entry parameters. Now, importantly, parameters can have default values. So here, for example, I have my function double with a number and a message, and the message by default has the value double is. So let's try this out. Here I have my double function. I'm going to create another double function. Okay, let me just comment this out for now. You don't actually need to comment this out. If you have 2 functions with the same name, they are called overloaded functions, and we will see those in the next video. But for now, I'm just going to keep this commented out, and I'm going to have here a number of type int and a message of type string, and I'm going to give it a default value, double is. Okay, and here I want to simply print line my $message and expression number times 2. Okay, so here if I call, I already call my double with 5, so if I only call it like this, okay, then the message parameter will have the default value double is, okay? But I can also define another message. So I can say double of 8 and something like 8 times 2 equals. Okay, 8 times 2 equals. And in that case, the message will be whatever I provide, right? Because it is no longer the default value, it will take the value that I provide here. So that will work just fine. And that will give me double is 10 and 8 times 2 equals 16. Okay, there we go. I think that is fine. I've put a space here and a space here, so that's why I get 2 spaces here, but that's fine. I'm okay with that. All right, so parameters can have default values. This is my example. Now, let's talk about return. So a function can return a result. Okay, so for example, here we have a function called calculate circle area. There is a formula using pi. I'm going to simplify pi to 3.1415. Okay, and this function can simply return the area of a circle with a particular radius. Okay, so let's try it out. In order to return a result, you have the return keyword and whatever expression you want after that return keyword. Okay. Also, I should mention here that the return type is also defined here in the function definition. After your parentheses where you define the input parameters, you have a colon and the return type. Okay, this is optional if you want to return it. If a function doesn't return a parameter, then the type doesn't need to be defined, obviously. But if you want to return it, you need to define that type. Okay, so let's try it out. I'm going to create my function here, calculate circle area. And I'm going to have r as integer for radius, and I will return a double. Okay, I'm going to define my pi equals 3.1415. Sorry, it's 3.1415. And then I will simply return pi multiplied by the area squared. So multiplied by r, multiplied by r. Okay, so that is fine. Now, in my main function, I'm going to say val r equals, let's say, 27. And I'm going to print line a message, a circle with a radius of $r has an area of $, expression, and I'm going to call my function, which is called calculate circle area, with the parameter r. Okay, so that should give me a nice message to tell me what the area of that circle is. Okay, let me just run this. Oh, I think I moved something inadvertently. There we go. All right, that is working fine. So a circle with the radius of 27 has this area. Okay, I am multiplying by pi times r squared. Okay, so basically we are simply returning a parameter of type double. Okay, you can see that I'm not printing anything in my function. I'm just returning a value, and I'm using that value to print out this message. Okay, so I'm just calling this function. Now, there's an easier way to return something from a function. If you can, in a function, if you can put everything on a single line, you can simply return that line directly. Okay, so let me just change this function a bit. Fun, calculate circle area with an r of type int. Now, instead of defining the type that I want to return, I'm going to simply return it. So I'm going to say equals pi, which is 3.1415, multiplied by r, multiplied by r. Okay, so the system already knows that I want to return something because I have this equals parameter for my function, and also knows the type that I want to return since I'm already returning it here, and it can understand what type it is, right? Since this is an integer and this is a double, the return type is going to be double. So this is kind of a shorthand way to return a quick result from a function, but that only works if you can write everything on a single line. If you have multiple lines and different other functions that you need to call, well, obviously this is not going to work. So you need to use the standard way to define your return. But if you can put everything on a single line, then this is a nice shorthand way to return the result. So with that, I'm just going to run the code and it should give me the exact same output, and that is fine. Okay, so here I have my return shorthand. So that is the basics of functions. We have a function that can be called multiple times, that can take some parameters. Some of them can have default values. What I forgot to mention here is that you can actually, when you're calling a function, so let's say for this double call, now I can define the parameters that I want to pass here in the order that I want. So here, for example, I can say message equals, what was the message? 8 times 2. 8 times 2 equals. And then I can define my, number equals 8. Okay, so these are named parameters, named calls. Okay, so if I have, let's imagine I have a larger function with multiple parameters, let's say 4 or 5 parameters, and I only want to provide some of these parameters, then it is very useful to have the named parameters here, because some of these parameters can have default values, whereas some do not, right? Or I want to provide only some default values and leave the others as they are. So that means I need a way to kind of specify which parameters I want default values and which I don't. So in that case, I can simply use the names of the parameters and give them values individually. And the order doesn't really matter anymore, right? If I don't name my parameters, the order is important because the system will take the first parameter and match it with the value, then the second with the value, and so on. But if I name my parameters, then it doesn't really matter. The order can be anything I prefer as a developer. All right, so I think that is all. We have functions, we have call parameters, and we have return parameters and return values from our functions. In the next video, we will look at a bit more, some more advanced topics around functions. Okay, I will see you there. In this video, I want to talk a bit more about functions, and I want to introduce you to a few more concepts related to functions that we haven't talked about. So the first one is overloading. Basically, this means that two functions can have the same name if they have different numbers or types of parameters. So the main idea here is that the system determines what you are trying to call, which function you're trying to call, based on both the name and the call parameters, right? So that means if you have a function with the same name but different parameters, different numbers, or different types, okay, then the system can differentiate between those functions, and then you are allowed to have the function with the same name, okay? Now, why you might want to do that? Well, it's simply because you might want to provide kind of similar functionality in a single function name, but if you are providing different numbers of parameters, then that functionality can be kind of customized, right? So in essence, if the function conceptually or multiple functions conceptually are doing the same thing, then they can have the same name but different parameters, right? So let's have a look at an example here. Let me just first create a new file, morefunctions.kt, fun main. Okay, now let's create a function called multiply. So fun multiply with a single parameter, let's say number of type integer. And that's going to simply multiply the number by 2. So that's going to be equal to number multiplied by 2. And I'm going to overload this function to give it the possibility to multiply this number with a additional parameter instead of just 2, right? So fun multiply number of type int. And I'm going to have another parameter, multiplier of type int as well. And I'm just going to return number times multiplier. Okay, so you can see here that I think I have an error here, conflicting overloads. So the only issue here is that in the same project, I have defined another function called multiply. So I'm just going to comment this one out. Okay, coming back here, that solves my problem. So if you have the same error, then you know why that happens. Okay, so like I said, the main idea here is that we have the same function with the same name, but different number of parameters. And here I can simply call multiply 3, and I can also call multiply 3 and 8. Okay, so both of these calls are fine because the system knows which one I'm trying to call. Now, you could say that we could do the same thing if we have a function like this. So let me just comment this out. And we could have a function like this with a default value of 2. Okay, so this one works fine and this one works fine as well. Yes, it is kind of the same thing in this example. It really depends on your system, on your project, what kind of makes sense for your project. Does it make sense to have multiple functions with the same name that do kind of similar things? In this case, we do kind of the exact same thing basically in the two functions. So that's why this way of writing the function works fine. But in a real world situation, your different functions might do kind of conceptually same thing, but in practice different things. So for example, you might want to get some data to display on your screen. So you might want to contact either a database or a API over the internet or wherever that is, local memory, whatever. So the function might be the same name, but the functionality is completely different, right? So in that case, you might want to have two separate functions, even though they are called with the same name. All right, so that is overloading, basically number and type of parameters. Now, another concept regarding functions is that you can have a variable number of parameters. So here in our function so far, we have defined functions with an exact number and type of parameters, right? We have 2 parameters here, we have 1 parameter here, we have 1 and 2. But it is possible to have a function that can accept a variable number of parameters. And the way we do that is with the var arg keyword. So let's go ahead and create a function, say hello. And here, instead of the usual parameters, I'm going to say var arg, variable arguments or variable number of arguments, var arg names of type string. So this function will accept as many string parameters as we want to give it, right? So this will be basically a collection, and we can use that collection to perform some functionality. So I'm going to create a for loop here, name in names, and here I want to simply print line hello $name. Okay, so I'm going to just print out a hello message for all the parameters that are given. So with that, let's go ahead and call our function say hello. And here I can pass whatever parameters I like. So I have Mary, I have John, and let's give one more. I have Alex. Okay, so as many as you like, there's really no limit. And you can see here that the IDE will give you an indication. It will say ... names. So many names, as many as you like, but they all need to be of type string. So if I just run this code, this should basically print out hello messages for all these 3. So hello Mary, hello John, hello Alex. Okay, so that is var arg. Of course, they don't have to be strings, they can be any type, but you can provide them here. Okay, now let's talk about local functions. Basically, a local function is a function that is inside another function. Right? So as we've seen before, inside a block of code, we can put pretty much anything you like, whether that's in a for loop or in a while loop, in an if block, or in a function. We can put other functions as well. Okay, so let's create a function here. I'm going to say fun. I'm going to have a function called list animals. Okay, and that's simply going to print out some message for a particular animal. And here I have no parameters. And inside this function, I'm going to create another function called list1animal. Okay, and I'm going to have animal of type string. And for this one, I'm just going to print line a message. I have a $animal. Okay, whatever that animal be, cat, dog, whatever. So inside here, I'm going to have a val animals or my animals. That's going to be a list of no type. I'm just going to have cat. I'm going to have a dog. I'm going to have, let's say, a cow and a horse. Okay, so I have my animals, and I want to, for each of these animals, I want to call this list1animal function. Okay, for animal in animals, or my animals, here I'm going to say list1animal with my animal. So if I call this function somewhere, let's say here, list my animals, this is simply going to loop through my list of animals and then call the function for each one and then print out a message. Now, this function doesn't do anything really crazy, but it does serve to emphasize the point that you can have functions inside functions. Okay, so if I run that, I have cat, dog, cow, and horse. Okay, so that works fine. But this leads us nicely to the discussion on scope. So as I mentioned previously, we've seen in other videos that scope affects how variables are accessible. Okay, so a variable that's defined inside a function, for example, my animals, cannot be accessed outside of that function of that scope. Okay, so this will give me an error. But it's not limited to variables. It also applies to functions. So for example, here, the function list1animal only exists inside of this scope. Okay, so inside this larger function. So if I try to access, let me just copy this. If I try to access this function here, it's out of its scope, so it's not going to be able to be called. Okay, so that scope is really important. It really depends on where you define a function that you can access that particular function. Okay, so scope is really important when we're talking about basic Kotlin, but also when we will talk about object orientation, scope also might be even more important there, right? It is a critical thing to know the scope of your variables and try to limit it yourself if you think that a variable needs to be used only inside a particular scope. Okay, an important thing to keep in mind, but I think that is all that I wanted to say in this video. Yep, that's it. In the next video, we will talk about even more advanced topics regarding functions, and that is the Lambda function and the higher order functions. Okay, I will see you there. In this video, we're going to talk about a couple of more advanced concepts around functions, which are lambdas and higher order functions. Okay, so let's start with a lambda. A lambda is basically an anonymous function, meaning that it will have no name. Okay, so basically we can define a function that really has no name, but can have parameters that can be declared at the start of the block. So what I'm going to do here is I'm going to introduce this concept of lambdas, and then we're going to use it to talk about higher order functions. Okay, so this is where kind of Kotlin gets a little tricky to understand if you're coming from like no experience in development. But this is also a concept that is very flexible, and once you understand it, it will allow you to kind of, make your code a lot more efficient and a lot more I would say readable, although at the beginning it might be a bit tricky to read, but once you understand the concepts, it will make your code a lot better. Okay, so let's introduce the concept of lambda first. So let me just create a new file here, lambdas. Okay, fun main. Okay, so a lambda is basically a function. So we can say print line, okay, hello world. Okay, whatever the name is. Now, by itself, it's not really useful to have anything like that because nobody is calling this, nobody is using it. It's basically just sitting there, right? So a couple of things here. First of all, you can have input parameters. So I'm going to define an input parameter here, name of type string, and then an arrow sign, string with a G. Okay, so name with an arrow string, and I can say, instead of hello world, I can say hello name. Okay, so as it stands here, this is basically a function without a name and without any practical use, right? This is what we call a lambda. Now, lambda can be assigned to a variable. So we can assign this lambda to a variable. So let's say val my lambda equals this function. Okay, so right now, even though the function doesn't have a name, it still has a variable, and that variable has a name, right? So we can actually manipulate this function, and actually we can pass it along. So you can think about how a regular function will have some parameters. Those parameters can be primitive types, they can be complex types like collections, but importantly, they can also be functions. Okay, and this is where lambdas come in. Lambdas allow us to pass a function as a parameter into another function. Okay, now a variable can be passed as a parameter to a new function, and that is what we call a higher order function. A higher order function is simply a function that takes another function as a parameter. Okay, so we have seen something similar previously when we talked about functions defined inside other functions, right? So instead of defining the function inside like this, we can instead pass it as a parameter. Okay, so let's go ahead and try that out to see how that might work. So let me define a higher order function here. Let's say I call this say hello. And here, let me put a block of code. And here I want to have two parameters. First of all, I want to have a parameter names as a list of string. Okay. And I want to have the second parameter, I want it to be a function. So the function is going to be do something. And the way we define the function parameter is we're going to say it's a function that takes a string, for example, and returns nothing. Okay, if it returns nothing, we need to provide the keyword unit. Unit simply says this function returns nothing. Okay, there's nothing to return here. Okay, so I have my higher order function, which takes a collection and another function. Now, inside this higher order function, I want to simply apply this do something function to my names. Very similar to what we've done here, right? We apply a function to a list. So we're going to do the same thing, except with lambdas. So for name in names, I'm going to simply do something. And you can see now that I have my do something, which can be invoked. Okay, so I can say with name. Now, inside here, since I have defined a function, we can use this name of a variable as a function call, but also we can use it as a simple variable. Okay, this is my variable, and my variable is a type of function. It's a lambda. But here we're going to simply use it as a function call. Right, so we have our lambda, we have our higher order function, which simply applies the lambda to some parameters, and then it's time to call. So here I'm going to instantiate my names list. So I'm going to have a list of, what are we going to say? Mary and Kate and Mike. Okay, so I have my list of names, so I can call my higher order function. So I can do say hello with my names and my lambda. Okay, so let's go ahead and run this. So far, I hope you can kind of follow along, because it is basically what we've done here. We've defined a function inside another function, and we use it to call that function with a list. The only difference is that we have moved this function definition from inside the function to outside, and we've made it a lambda. Okay, so that allows us to pass it in the parameters. But this is actually a very powerful thing, that we can pass functions along, and you will shortly see why. So if we have run the code, we get hello Mary, hello Kate, hello Mike. Okay, so this is my higher order function. So this is the basics. This is basically all there is to it, to lambdas and higher order functions. Of course, my lambda in my example is very, very simple, but you can see here that my higher order function can take basically any lambda. It doesn't have to be a simple print hello world. It can do pretty much anything you like, anything you need for this function, right? So with that in mind, we're going to talk about a few higher order functions that are very useful and very common in development. And the first one is for each, which basically applies a particular lambda to a list of elements, very similar to how we've done our say hello. Okay, this is basically the for each function. All right, now for all the higher order functions that we're going to talk about, I'm going to have a collection. Let's create it now. Val clients is going to be a list of, so I'm going to have a list of clients, Anna. I'm going to have Bob, Carol, and let's say David. Okay, so I have my clients. Now I want to apply some functionality to all my clients. Okay, that's going to be basically our say hello function, but it is a part of Kotlin. So you don't really need to define this function every time you need this functionality, which is going to be actually very useful. So I'm going to say clients.forEach. Okay, now how do we, here is a quick tip. If you have a hello world, similar to this one. So if you have a higher order function with some parameters and then finally a lambda, you have a shorthand way of calling that functionality. Okay, and here is how we do it. We have our for each, and we can simply say, we don't need to put our parentheses, we simply need to put our lambda here, and I'm gonna have print line hello $it. It is the parameter that is passed here. So what this does is basically it takes the clients, which is a list, it goes through it one by one, it takes one element, it's named it, and then it simply calls hello it. Okay, so let's go ahead and run this. Okay, and I'm gonna get hello Anna, Bob, Carol, and David. Let me just remove this function call so we can see it more clearly. So basically here, I hope you kind of understand, I hope it's pretty clear. Basically, we take this, this collection, which has a for each function. So we're calling the for each function of the collection with this lambda. Okay, since if I command or control click on this for each, let me just wait for that to finish. There we go. So we can see that the for each simply takes one lambda as a parameter, right? So if the function takes a lambda as a parameter, we have this shorthand way of calling it with the curly brackets here. And also, one more thing I wanted to mention, if you want to rename this parameter, instead of it, I want to have, let's say, name. I can do it like this. I can say name as a parameter, and I can use this parameter name inside my function call. Okay, so I can give that parameter a name, but if I just have one parameter, I don't need to name it. I can just call it it. Again, it is only if you have one parameter. If you have multiple parameters, then you need to name each one separated by a comma. So there we go. We have our first higher order function that is applied to our clients. Okay, so the clients defines this for each function. Okay, so clients dot, we can see that we have our for each function here, and it has a lambda. Okay, so that is the for each. Basically, for each applies this lambda to each element in our collection. The next higher order function we're going to have a look at is filter. Basically, it allows us to filter the elements of a collection based on a predicate, quote unquote predicate. It is basically a lambda that returns true or false. Okay, so here I'm going to say clients dot filter. Okay, so we filter the elements of a collection, and we're gonna let it pass. The predicate is gonna be it dot length of the element is smaller than 5. So if we have anyone with a length smaller than 5, then we apply the function and we let them pass. Otherwise, for Carol and David, that's not going to work. So if I say afterwards, if we chain these lambdas, if I say for each, and I'm going to use the same thing. I'm going to use print hello world it. Okay, I'm going to just comment out the previous one. Now, what do you think this is going to do? So basically, the clients dot filter is going to go through each element, and it will only let it pass. So it will only add to the final collection the elements that have less than 5 characters. So Anna is fine. And then I'm going to call for each in that final collection. That's going to be Anna and Bob. Carol and David do not pass. So I'm going to have that new collection. And for each, I'm going to say hello, the name in the list, right? So that means this whole line is simply going to print out hello and Anna, hello and Bob. Carol and David do not pass our filter, right? So let's go ahead and run this code. And we get hello Anna and hello Bob. Like I said, Carol has 5 characters as length, so it does not pass our filter, so it doesn't get passed into the new collection. Okay, so that is filter. Now we have map. Map basically transforms a collection into another. And how does that work? Basically, it takes each element and applies some function to it and spits out a new collection at the end. So here I'm going to have val new collection, new clients. I'm going to have clients dot map. Okay, so I'm going to map the clients collection to it dot length. Okay, so here I'm going to have a collection of lengths. So if I just go ahead and print line new clients, then that should print out 4355. There we go, 4355. It's basically the collection of lengths of these names. Okay, so that is map. Now I'm going to talk about sorted by. Basically, we're going to sort the collection. And I'm going to use it.length here as well. Val sorted clients equals clients dot sorted by length. Okay, and I want to print line my sorted clients. Okay, and then that is going to give me the same collection, but in order of length. So Bob, Anna, Carol, and David. 3, 4, 5, 5. Okay, so that is sorted by. We're gonna get the max of a particular collection. So for example, max by or null here is basically going to get, if we pass the length, is going to get the character with the most, with the biggest length. Okay, so here I'm going to say val max is going to be clients dot max by or null. and I'm going to have it.length. Okay, and if I print line max, that should give me Carol as an output, right? Right, Carol. So we have 4, 3, Carol is 5. David is also 5, but it's not larger than Carol. So since Carol is first in the list, remember list is a sorted collection. Since Carol is the first one, it will get the max here. And then we also have the min by or null. Okay, so we're gonna print that out. Min equals clients dot min by or null it.length. Okay, and if I print line min, you can guess what that is going to give me. It's going to give me Bob. It has 3 as a length. Okay, so these are just a few examples of the higher order functions that we can apply to collections. If you want an exhaustive list, you can simply say clients dot, and you can search here for more higher order functions. So for example, last is a higher order function, and you have pretty much all of them printed out here. You have binary search, you have a lot of them. So check those out and play around with them. Like I said, it might take you a while to kind of clearly understand the concept. If you need to, go ahead and watch this video again from the beginning, because we go through how we define lambdas and how we call them, and then how we define higher order functions. Play around with these higher order functions and make sure you understand them, because they are very useful in development and very flexible, right? So they will allow you to kind of build very flexible, very efficient programs and algorithms. All right, so with that, this is all for this video. Thank you for watching. I will see you in the next one. All right, now in this video, we're going to start to introduce our concept of object-oriented programming. So object-oriented programming, before we get into it, I want to kind of say that this is basically a huge topic. It does take a long time to kind of wrap your mind around it if you've never worked with it before in other languages, right? So don't stress out if you're not going to pick up everything immediately straight away. It does take some time to get used to the idea. If you're coming from what we've done so far, which is kind of functional programming, and also in this kind of abbreviated Kotlin course, I don't really have the time to kind of get into it in greater detail, as much detail as it kind of requires to pick up from scratch. Here, I try to cover all of the necessary topics, to be fair, on a pretty high level. So I'm going to introduce the topics, and hopefully I will give you some examples, of course, but hopefully as we go through the course and as we start to work on Android, you will kind of pick up the concepts more and more, right? And understand them better. If you do want to get a lot more detail about this and about the other topics in Kotlin development, check out my other course that is completely focused on Kotlin. It's much longer. I think it's about 30 hours, even more now because I've added to it. So check that out if you want a lot more details. But for now, I'm just going to kind of introduce the idea of object-oriented programming, and we're going to put in place a bit of code to kind of help you understand how we work with it. So object-oriented programming is kind of a different paradigm. So far, we've only used functions and kind of linear progression in our application. This is completely different. The main idea here is that we work with entities in program that perform certain tasks. So in the real world, you might think of, let's say you want to go from point A to point B. You might have different options, right? You might take a car, you might take a train, you might take a bus or a plane, depending on the requirements, right? So these are the entities that we want to focus on. An entity basically will be completely contain a task. So if we think about a car has certain properties, right? Like the brand, the speed, a lot of functional properties. but also it has functionality, right? It can take you from point A to point B. Okay, so tasks are completely contained in the object. That's how we kind of think of objects in or object-oriented programming as well. We have this concept of an entity that has some properties and that has some functionality. And the main idea here is that we can replace these entities with similar entities that perform the same task in a different way. So in the context of IT, you might think of, let's say, a network communication device that allows you to retrieve data, but also that data can be retrieved from different sources, right? So this entity of network communication can be replaced with a database storage, for example, or a local memory storage that performs the kind of the same task, right? Just retrieving data, but in different ways. So for that, we introduce the concept of a class. A class is the kind of the blueprint for the entity that we talked about. The entity, by the way, is going to be called an object. So the class is the blueprint through which we create the objects that we have in our code. So we define a class with the class keyword, the name of the class, and we have the curly brackets that contain the class code and functionality. So a class can have variables, okay? So these are the properties of that entity, and it has methods and functions, which basically allow the entity to do some functionality, to perform something that is useful for the application. As for the naming convention, basically the name should start with a capital letter. Other than that, there's not too many naming conventions. You have the camel case here as well, but the naming convention with the capital letter simply indicates that this is a class. Now, from the class, from the blueprint, we can create objects. So object is an instantiation of this kind of blueprint, right? So the object is what we manipulate in our code to perform some functionality. So for example, here I create two objects from the same car entity. So I have my car and your car. Okay, we can see here that car has two variables. One variable has a null value by default. It is a string, and the variable top speed is 100 by default. Okay, so here I can change its values without impacting the other object. So if I change the value for my car and I call it a BMW, your car can be Toyota. So these variables are different for the different instantiations of my class. And then we can simply call the various methods that we have. So here, for example, I call mycar.start and mycall.drive with 50 as a variable. Let's have a look. Drive with a particular speed, driving at a speed of. This is just what it does. So I can call these methods or these functions independently for my two objects, okay? And they will print out maybe different things depending on the object properties, or maybe the same thing if we don't depend on the object properties. Right, so let's have a pause here and let's move to our code and implement this code in our IDE and try it out for ourselves. So let me just create a new. Now here, I want to show you something interesting. You have the option to create a Kotlin class. You also have Java class, but don't select that because that will create a Java class. This is a Kotlin class or file, and you have here a class. And you have multiple other types of classes that you can create. And we will look at, I think, most of these. Yes, I think maybe all of these we will look at separately in a few videos time. But for now, I'm just going to create a OOP class. And you can see that automatically the system has created the class OOP for me. Right? Now I want to rename this to car. Okay. But the file is still going to be called OOP because we're still talking about simply the foundations of this idea, of this concept. So here, let's implement our class car. So I'm going to say var model of type string with a question mark and a null value by default. and I'm going to have a variable top speed that's going to be 100. And I'm going to create two functions here. I'm going to have fun start, print line with a string starting the $model. And the second function is going to be fun drive with a particular speed, so speed of type int. Okay, these are just basic functions, print line, and here we have the text driving at a speed of $speed. Okay, we're looking for this speed, not the top speed. So we have defined our car with two variables and two functions, right? So these functions only apply to instances of car. So if I have here down below, if I have my main function, I cannot simply say start. Okay, this is not going to work simply because the start function is dependent on the class car. So we actually need an instance of this class to call the start function. So here I'm going to create two instances like I've done in the example. So val my car is going to be, now I want to create an object of this car class. So I'm going to have car with parentheses. The reason we put parentheses is we will see later on, we can actually have parameters for the creation of a class, of an object. But for now, this is simply without parameters. So I'm just going to create my object like this. And then val your car. And that's going to be also a object of the type car. Right, now I have my two objects, so what can I do with them? I can change the variables. Okay, so I'm gonna say my car dot model. Okay, so this is the way we access variables or properties of this object. So my car dot property. So for the model, I'm gonna say BMW, and your car dot model is going to be Toyota. Okay, I can also change the top speed if I want to. I can say my car dot top speed, but I'm just going to leave it like this for now. Okay, here I can call the functions of my object. So my car dot, and you can see here I have start and drive. So let's call start, and then let's call dot drive, and I'm going to give it a 50 for the speed, and your car dot start and your car dot drive for 100. Okay, so if I run this, I'm gonna have this program print out the messages here. Okay, let's just wait for this to finish running. Okay, there we go. So starting the BMW, start driving at a speed of 50, starting the Toyota, driving at a speed of 100. So I hope you can kind of understand how this is starting to work. We have the object definition, which is the class, and we have the objects in our code. So this is our main code. Okay. We have the objects in our code that can perform some kind of functionality. Obviously, this is a very simple example. We're starting from very beginnings, but these objects can grow to hundreds or thousands of lines of code, and the functionality can contact other objects, other creations, and so on. We will see later on as we move through the complexity. Okay, in any case, so we have our two objects. That is all fine. Now, let's talk about, in general, about Kotlin. So in Kotlin, everything is an object. So we have studied strings, int, floats, lists, array lists, hash maps, and so on. Actually, list is a separate thing that we will learn later on. But array list is an object, hash map is an object, everything is an object in Kotlin, right? So string, int, and float, boolean, and so on will have certain properties and certain functionality as well. Array list, we have seen, again, we have properties such as length, how many elements is are in that array list, and it has functionality, right? Like we can say dot put, or we can add, remove other collections, and so on and so forth, right? So these work because array list is an object of a class. Collection and list are interfaces. Like I said, we will talk about that later on. Now, I'm going to introduce an important concept here, which is inheritance. Inheritance simply says that one class can inherit the properties and the methods from another class. Okay, so we can take the same structure for one class, add it to another class, and add a bit of functionality on top of that. Okay, so a class can inherit from another class. So what does this mean in practice? Let's say we have our class dog. You notice here the open keyword. This allows this class to be inherited by another class. So this class is open to inheritance, right? So our class dog has a size, a property, and it has two functions. It has bark and it has play. And we can inherit from that class. So we have another class corgi that inherits from dog. This is how we define inheritance with a colon. So this means that the class corgi will have all the properties and functionality of the class dog plus whatever it defines itself. So the function look cute is going to be specific to corgi but not dog. Okay, but the function bark and play will be both for dog and for corgi. Okay, let's go ahead and try this out. I'm going to define a class here called dog. Okay, now I'm going to mark this as an open class and I'm going to have some functionality here. Okay, so I have my class. Let's go ahead and create a var size of type int equals 0. I'm going to have a function bark, which simply prints line a message barking. And I'm going to have a function, play, which simply has a function print line playing. Now, underneath that, I'm going to have another class corgi, which inherits, so colon dog. Will inherit everything from dog, and corgi simply adds a function look cute. Okay, and we're going to print line cute puppy. Okay, so I now have my two classes, dog and corgi. Corgi inherits from dog. So I can use these classes here. I can say, well, my dog is going to be a corgi. And I want to show you here that I have all this functionality. So print line, my dog dot size. Okay, so we can see that my dog will now have a property called size. I should define this by default, whatever size means, like 20. Okay. Okay, so I have my dog dot size and I have my dog dot look cute. So we have this functionality that was defined in the corgi class, but we also have my dog dot bark and my dog dot play. Okay, so if I run this, I'm going to get the printout for the size, which is 20 by default. Okay, I get look cute, so cute puppy, barking, and playing. So you can see the idea here. Basically, this corgi class will inherit everything from the dog class. So it will be as if those properties and functions are available in the corgi class, even though we didn't define them here. Okay, this is one of the main ideas of object-oriented programming, and that is we can inherit functionality from another class. And we will see later on how we can both inherit that functionality, but also override that functionality to change it a little bit. Okay, so we want something different. For example, here I could have a different method for barking, right? But for now, we're going to leave it at that. Before we end this this lesson, I want to show you a quick trick in your IDE to find out more about a class. So for example, if I'm here in main, I have my object of class car, if I hold the command key or control for PC and I click on the class, okay, it will go to the declaration. So it will go to the class definition. Okay, so that works well if we've defined it here in our own code. But let's go down here. And as I mentioned, everything is a class. Everything is an object in Kotlin, which means int is an object. So if I command or control click on int, that will take me to the int class definition, which is in the Kotlin functionality itself, right? We have here primitive.kt. So as I said, everything is a class, everything is an object. So the int is also a class. We can see a public class. The definition is much more complex than we have seen so far. It is normal, but of course we will look at all of these separately, right? We will look at constructors, we will look at companion objects, everything we will study. So yeah, this is the definition. So in general, when you have a class where you're not sure what it does, you can just go to its definition and check it out. This is much too complex for us right now to check out, but it's a good trick to know that you can command or control click on that class to find out more about it. Okay, so that is all I wanted to say about OOP for now. In the next video, we will look at more details about other stuff you can do with classes and objects. All right, so in this video, I want to introduce a few more concepts that are very useful and very common in classes. So you will kind of encounter them all over the place. The first is the constructor. The constructor is basically a way to provide some variables and some values to your object creation. Okay, and it works really simply. It's very similar to a function, okay, at least for this case. First of all, let's say we have a class vehicle. We have two parameters, model and top speed, and we want to provide those values at creation time. Okay, we don't want to provide a default value. We just want to simply give them as a parameter. Okay, so we can simply create the object with two values. So let's go ahead and try this out. So I'm going to create a new Kotlin file, constructors.kt. And here I'm going to have a class vehicle. Okay, now inside my class, I'm going to have two parameters. I'm going to have val model of type string. And you can see I don't provide a default value, so it has to be given when the object is created. And I have var top speed of type int. Okay, so how would I create an object from this class? I have fun main val my car is going to be vehicle. Okay, and you can see here I need model and top speed. So I'm going to say, let's say BMW and 200. Okay, so that is how I create my object. If I just go ahead and print line my car dot model, that should give me the BMW as a printout. Okay, so that means my vehicle has a BMW, has a model parameter. But this is not the only way to create to make a constructor. A class can have multiple ways of being created. It depends on how we want to instantiate that class. And since it will have multiple constructors, then each constructor is used depending on parameters, right? So the system chooses the correct constructor based on the parameters we provide. So here, in my class, if I want to have multiple ways of instantiating my class, let me just comment this out and I'm going to go ahead and create it again, class vehicle. Okay, I'm going to remove the default constructor here. Okay, and I'm going to have a few different constructors. The way we define them is with the keyword constructor. So I'm going to have a default constructor with, let's say, no parameters. First of all, if I have multiple constructors, I want to define my parameters in the class. So var model of type string, and I have to give it a default value, and let's give it null by default. And I have var top speed of 100. Okay, so I have my first constructor, which basically simply instantiates the model and top speed to something default. Okay, so model equals no model, and top speed, let's say 100 as we've set here. But I can also have multiple ones. So I can have a constructor that simply takes a new model variable of type string and says model equals new model and top speed equals 150. Okay, so that's one constructor. I can have another one that instantiates both my variables. So new model of type string and new speed of type int. And I have here model equals new model and top speed equals top speed. Okay, so you can see now that we have basically, top speed equals new speed. There we go. So we have now three constructors. We have the empty constructor, which is going to be by default. We have the constructor with one parameter and with two parameters. So here I am now using the constructor with two parameters, but I can also have val your car equals vehicle of, let's say, only one parameter. Here you can see the options that we have. We have no parameter, 1 and 2. And here I can say new, I can say, what is it, fiat, for example. And then it will use this constructor with the top speed of 150, but also I can have val her model, her car equals vehicle with no parameters. Okay, so I can also print line here your car dot model, for example, and print line her car dot model. Okay, so let's go ahead and run this. Not sure which one was default. Right, so no model was default, BMW, Fiat, and no model. Right, so basically three ways to create objects from this one class vehicle. All right, so that is the constructor. You will use the constructors quite a lot, and a lot of classes have multiple constructors, so it's very useful to know. Now, getters and setters basically allow us to change the way variables are assigned and retrieved. So what this means is that at the moment, for example here, with the model and top speed parameters, I can simply change them as I like. So I can say my car dot model equals something else, right? But I want to add some functionality, or I might want to add some functionality when the variable is changed. So in that case, I have the getters and setters. And for that, let's go ahead and create a new file here, getters and setters.kt. And I'm going to create a class here called car2. Okay, I cannot say car1 because I've already defined another class car. I think it was here, right? So I already have a class car, so I need to put car2. Okay, now again here, keep in mind that we can use, since we're in the same project, we can use classes that we've defined previously, right? So that's why the names have to be unique here. Now for this class car2, I'm going to have two parameters. I'm going to have val name equals empty by default, and I'm going to have, let's make that a var. And I'm going to have a var speed of type int. And in order to be able to set this speed, I want to, at the same time, set the name of my car too. Okay, just a random requirement that was given to us by the project manager for some reason, right? So I want to, when we set the speed, I want to be able to set the name of the car as well. So I have here the option to provide a getter and a setter. So for the getter, I want a get equals 50 by default. So what this means is whenever I try to retrieve this variable, to print it out, for example, I will get the value 50. That is the default functionality. And also I have a setter with a value, which means that whenever I try to set the speed to some value, I can provide some other functionality here. And instead of equals, I have a block of code. So here I have name equals high speed car $value. So what does this do? Basically, it allows us to set the speed to whatever value we like, but also to run some functionality. And in my functionality, I want to update the name of the car as well. So let's try it out. Let's see what we have here. Fun main. Okay, so here I have val my car equals car2. Okay, my car, I want to set the speed to 100. Okay, so what does this do? Let's try to then print line my car name dollar my car, I need an expression here, my car dot name, and then I want to print line my car speed. Again, expression my car dot speed. Okay, so let's run this and see what we get. So what this does is basically when we try to print out the name here has been updated to this value, right? So high speed car 100. 100 because we passed the value 100. Now keep in mind, the 100 will not go to the variable speed in this case because we have changed the way we set that value. So the setter simply updates the other parameter, right? I hope this kind of makes sense a little bit for you. So 100 will basically update the name. However, when we try to print the car speed, then we invoke the getter, and the getter will simply provide us with the value of 50. Okay, so that's why we're kind of playing around with the creation and update of these variables, right? This might be a bit confusing. So again, this is one of these concepts that you might use or see in code, and you kind of need to understand what it does. You're probably going to use this a little bit less than other concepts, but it's important to know that it's there. Okay. Now, one thing to mention is that getters and setters are completely optional in Kotlin, right? So if we don't provide them, they will be created by default and invisible to us, which will simply update. They will simply update the variables and retrieve the values. So you don't have to worry about them if you don't need to set some particular functionality, but sometimes they are useful, they are required. Okay, custom getter will be called every time we access the variable, and the same for the setter when we try to set a value. All right, so moving on from the getters and setters, we have the this keyword. So this keyword refers to the parameters of the specific class. How do we use this? Actually, this is quite useful to know about, very important because we use it quite a lot. Here I have a new file, this keyword.kt. Okay, here let me just create a class post-it note. I don't need the constructor. And this class has a simple message variable, and by default is no message. Now let's create a function to update message, and this function takes a message parameter, message of type string. Now here is the dilemma. If I want to call this function update message, and I want this message parameter to update my message parameter in the class, how do I separate between the two? Now you might want to ask, why don't we just rename this variable? And it is quite a decent question. You know, you could rename this to something like new message. Okay, but that simply introduces another parameter, another value, another variable here, right? So it's often the case in development that we want to name this variable exactly the same as the variable that is being updated, so that there is less confusion. And in this case, there's an easy way to differentiate between the two. We access the class functionality, class variable, with the this keyword. So we can say this.message, and this one will refer to the class parameter, is going to be message, and the message will refer to our parameter in the function call. So this.message equals message will update the variable in our class. Very common use case, we use that quite a lot. So you will encounter it pretty much all over the place. So here, if I say val post-it equals post-it note, object creation, and I want to print line my post-it.message, then I want to update. So post-it.update message and say meeting at 5, and then I will print line again post-it.message. Okay, so let's go ahead and run that. So the main idea here is that this keyword is used to refer to the class variables rather than the function variables inside this scope. So here we have no message at the beginning and then meeting at 5. All right, so this keyword, like I said, you will encounter it in quite often in code. Now, the init block is another construction in your class that will basically allow you to run some code at the creation of the class. Okay, it is run before any other code in the class, and it is simply run when you create that class, the init block. So let's go ahead and create a new file, init block.kt. Let's create a class car. I think we are at number 3 here. Okay, let's have a var model equals no model. And we have a var top speed of, let's say, 100. So I want to create, to add some functionality when this class is created. And I want to simply print line a message model dot $model top speed dollar top speed. Okay, so init block, basically the init keyword with a block of code after it. You can have pretty much any code you like here. Fun main. Okay, I'm gonna have val my car equals car3. Okay, and that will basically create the object, and at object creation, it will automatically run the init block code. Okay, so if I just run that, you can see that the variable my car is not used. It is grayed out here, but even then, even if we don't use it, we still get the printout model no model top speed 100. Okay, so init block, very, very useful. Allows us to run whatever functionality, whatever code we like at object creation time. Okay, it provides functionality in addition to constructors. So if we have 20 constructors, we can still run the block, whatever the constructor does. And then finally, I think this is the last one that I'm covering in this video. It is the companion object. The companion object allows us to run some code statically, which means without actually needing to create an object from that class. So that is the static code. Let's go ahead and run or create a new file. Okay, companion object. Okay, companion object.kt, make sure that's there. Now here I have car4, and I'm not going to provide any functionality for this class. I'm just going to create a companion object with a block of code. Okay, and here I'm going to have a function get driving instructions that simply returns a string. Let me just do that correctly. So this is a basic function and will simply return drive safe. Okay, now I have my main function, and as I mentioned, in order to use the functionality of the companion object, I don't actually need to create an object. So I can simply say val message equals car4 dot get driving instructions. So you can see that I haven't actually created a car4 object like this, right? I just call the functionality directly. car4.get driving instructions, and then I can print line my message. Okay, so let me run that, and I will just get the instructions drive safe. Now, of course, I have my very basic class here. So in reality, in code, in a normal project, you would have the usual functionality for your class in addition to the companion object. Okay, but this is for an example only. So here I just have my car driving instructions functionality as a static function. Okay, I can simply call it without creating an object. Okay, so that is the companion object, makes class code available without needing an object, without instantiating the class. All right, so that is all for this video. I know I am kind of throwing a lot of concepts at you. And if it is literally the first time you encounter these concepts, then it might seem a bit overwhelming. I can understand that. Even if you do not kind of understand everything, and if you do not remember everything, please do not worry. We will see these concepts again and again in our Android code. And once you kind of start to use them a couple of times, you will get more and more used to them, more used to seeing them, and more used to creating them. And when we actually discuss or create our examples in this course, we will use these concepts quite a lot. So as time goes on and as you build more projects within this course and outside of it, you will get more used to these concepts. If you've seen these concepts in other development languages, then it will be quite easy for you to pick up, and this kind of introduction will be enough, because it's just another way of writing it. It's different from other languages, but it's also conceptually the same. All right, so that's it for this video. Thank you for watching. I will see you in the next one. All right, so in this video, we're going to talk about the 4 principles that relate to object-oriented programming. The reason I wanted to cover the 4 principles here is because they are quite common in software development in general, and you will kind of encounter them pretty much in any development language that you study. Also, they are an easy question in an interview or in a job situation, so you have better understand them and kind of remember them. And they're also very useful when you are actually building your application and building your code. So what are they? Basically, they are a set of guidelines that make a language object-oriented. That simply means that they are very high-level overview of how you are kind of quote-unquote supposed to build your code and supposed to structure your application so that you achieve certain aspects. So things like writing clean code, maintainable code, easy to understand when a new developer kind of comes in, easy to separate functionality and requirements, okay? Easy to structure your application into subcomponents so that they kind of work well together. Easy to maintain the code and debug it when necessary. Easy to scale when your application grows to a certain size. The 4 principles would kind of, if you follow them, they will allow your application to grow smoothly as more and more functionality is added. It will help guide you on how to divide your program into components. So you might think of, like, if you have a problem in real life, how would you go about solving it? You would apply the same principles in object-oriented programming. So for example, you might have a problem where you require different people to kind of work together to achieve a certain result, right? Let's say you have an application that you might want to sell, So that means you have to hire developers to build your application. You have to have people that come up with requirements. You have salespeople, you have marketing people, and so on and so forth. So this kind of thinking also applies to our coding, to our development. You might want to have a component that reaches out and retrieves some data. You might have another component that processes that data, one that displays the data, and so on and so forth, depending on the requirements of your application. This talk is kind of high level because the principles are very high level as well. So they won't tell you exactly which component to build at which point. They will basically give you some idea of how to structure your components. So let's skip all that and let's go and see what the actual principles are. So the first one is inheritance, that we have already talked about slightly. Basically, inheritance simply means that classes can inherit functionality and data and parameters from other classes. Okay, we are not simply limited to one class inheriting from another class, but we can also have multiple classes inheriting from the same class. So the same functionality can be distributed to multiple classes, and that is very useful because it will allow us to kind of use the same functionality without writing it multiple times, right? So you can imagine when you have a bug or a problem in your code, it is very useful to have one functionality in one place rather than having the same functionality in multiple places throughout your application. Especially since that functionality might itself have bugs, so you might need to fix it in pretty much all the places it occurs. Now, the second principle is encapsulation, which means that data and functionality and inner workings of a particular class needs to be encapsulated into that class and not accessible from the outside. So another class that is calling your functionality in your class doesn't need to know how some functionality is performed. It just needs to know what the outcome will be. Okay, so you can think about a system that retrieves some data from a data source. You don't really care what that data source is. It can be an API on the web. It can be a database. It doesn't really matter from the user point of view. It just matters that that data is available. Of course, where that data is matters to the class that actually retrieves that data. So that means the functionality to retrieve the information is encapsulated in our class. The next principle is abstraction, which means that a common feature of two classes must be abstracted into a third class. And this relates a little bit to inheritance as well. So if we have some functionality that is common between two components in our application, then we want to put that functionality into a single place. So that means when we want to update it, we update only a single place. When we debug it, when we test it, we test a single place. We don't test different components throughout our application, right? So that is abstraction, and that ties into inheritance as well, because since we are able to inherit from another class, that means that we have two classes which inherit from a single class that has the common functionality. Very, very important aspect. And finally, polymorphism, which we haven't talked about yet. We have touched on it when we spoke about functions. This basically means that a function with the same name but different ways of accessing it, right? We've seen that before, but this principle applies even more so to classes where we have the same functionality in our class with different parameters that can perform different tasks. And also it relates to inheritance as well, because we can inherit the same functionality from an abstract class. So it will have the same name, but it will be changed slightly in the child classes as well, right? So we have polymorphism, which means many forms of a certain thing. we can rename the functionality, the class, the function. We can rename that, but keep the functionality intact, or we can keep the name and change the functionality. So a very important principle as well, and we will see more. We will talk about this principle more in a few videos' time. So these are the 4 basic principles. Like I said, they are very high level, so you don't need to really worry too much about this. It just simply means that, you know, each principle kind of gives you an idea of what high level thing you should watch out for, like putting the same functionality from 2 different classes into one class, or inheriting you know, related functionality from a common class and things like that. So it's good to keep them in mind. Don't worry too much about them, but also don't ignore them completely when you are kind of structuring and building your application. All right, so in this video, we're going to introduce a very important topic, a very important concept, which is the concept of an interface. So what is an interface? Basically, an interface is a definition of a part of the class. So the interface is simply going to tell whoever is accessing this class what this class does. Okay, it doesn't have to be everything that the class does. It can be some part of it, or if you require, it can be everything. Okay, it doesn't really matter, but the main idea here is that you have some definition, some functionality that is presented to the outside object that is calling this class without actually accessing the class itself. So you can kind of think of the concept of encapsulation here, the principle of encapsulation. Now, interface is a definition of a part of the class. It tells you what a class or an object can do. So in practice, it will tell you the methods that are available to your caller, to the caller of this class. Methods and parameters, right? So it tells you what you can access. Now, importantly, we can access an object through their interface. So we don't actually need to know everything that the class does. If we are using an interface of that class, we can access the functionality through the interface. And we have actually seen this concept previously in code without actually knowing that we are using an interface. So let me show you what I mean. If we open up lists.kt, we are creating the list of letters. Now, list is actually an interface, okay? If I specifically mark this as a list and I just command click on it, I am taken to the definition of list, and you can see here that it is an interface, okay? So we've used this previously without actually knowing that list is an interface, but that is fine. We can still use all the functionality of a list through that interface, okay? So we can get, we have the get function, we have index of, and so on. All right, so we can access other objects through their interfaces and can be used as variable type. So as we've seen, we can define an object as a list, okay? And the list is an interface. But let's not focus on that. Let's go to our code and create our own interface. Okay, I'm gonna create a new file and I'm gonna call this interface.kt, interfaces with an S. All right, so what I want to do here is I want to create an interface. So interface for an oven. Okay, I want to create ovens and the interface is going to tell the system what an oven can do. So here, for example, I have var temperature of type integer. Okay, I don't provide a value. We will see shortly why. I have a function turn on. Okay, now interface doesn't actually provide you with implementation for that function. It just tells you what it does. Okay, so just a function called turned on and another function turn off. Okay, now I said an interface doesn't provide you with an implementation. In actuality, it doesn't have to provide you with an implementation, but it can if you want to do that, right? So let's put an example of that. Fun cook. Okay, and here we're going to provide some functionality for the cook method, and we're going to have print line cooking at $temperature degrees. Okay, so we don't have to provide the functionality, but we can if we want to. Okay, so we have our interface. Now let's create a class that uses this interface. So I'm going to have class Samsung that uses, so colon, oven. Okay, you will see here a similarity with the inheritance. So it's the same structure, except we don't inherit from another class. We implement, the term is implement, an interface. So class Samsung implements the interface oven. So when we implement an interface, it means that we take all the definition from that interface and apply it to our Samsung class. Okay, so what does this error message say? It says that the class Samsung is not abstract and does not implement the interface oven. So what this means is, in the interface oven, we have defined a couple of methods that have no implementation. And since we are using that interface in a class, we have to provide an implementation for our two methods. So what I could do here, and this is very specific to this particular IDE, okay, I could simply click on this error message and implement as constructor parameter or implement as members. If we want, I'm going to choose the members and I'm going to implement the turn on and turn off. Okay, so that simply provides me with some default implementation, but of course I want to change that default, especially since this kind of to-do will crash my program if it's not actually implemented. So in the to-do, I'm going to have just a print line, in the turn on, I'm going to have a print line turning on. And in the turn off, I'm going to have a print line turning off. What I also want to do here is basically two more things. I want to provide a value for my temperature. Okay, since the temperature is defined in the oven but not implemented, I'm going to instantiate it here. So I'm going to have temperature. Okay, so by default, this provides us with a lot of code. I'm just going to remove most of it and I'm going to explain what we're doing here. So let's say 200. So what I'm doing here is basically I am taking this temperature variable and I'm instantiating it in my class. For that, I need this keyword override. Override simply says that this temperature is defined in an interface that I am using. So I need this particular keyword to tell the system that I need to use this variable, not the one in my interface. Okay, override. And you will see this override code, override keyword here for turning on as well, simply because turning on is defined in the interface and implemented in my class. So I'm going to need the override here as well. All right, so I have my interface, I have my class. Okay, I want to have a function called something like oven factory that will simply provide me with an oven. And the implementation is simply return a Samsung. Okay, so I'm using this oven factory to provide me with an oven. So the caller of this function doesn't know which type of oven I have, it just knows that I have an oven. Of course, I could have another class here, Bosch, which implements oven as well. Okay, so I could have two types of oven or multiple. I'm just gonna simplify the code like this. Okay, so I have my oven factory and I have my main function here. So the main function will just allow me to instantiate everything. So I'm gonna have val my oven is going to be oven factory. So oven factory will simply return an oven. At this point, I don't really know if I have a Samsung or another type of oven. And to kind of show you that I don't know which one it is, I'm gonna have a separate variable here inside the Samsung oven. And let's say this is gonna be warranty years. And that's going to be 2, for example. Now, here I have my oven. I actually cannot use warranty years because my oven is an oven. It's not a Samsung. So if I say warranty, let me just copy that. Warranty years, that's going to fail because at this point, I don't know if it's a Samsung or another type. Like I know as a developer, but the system doesn't know here, right? So at this point in my code, I cannot use Samsung specific functionality. However, I can use the other functionality that is defined in my oven interface, right? So here I have my oven dot turn on. Okay, my oven dot, let me see, I have cook. Okay, and I have my oven dot turn off. Okay, so I have the functionality that is defined in the interface, but not in Samsung class. Okay, so let me just go ahead and run this. And that should just print out the messages for the oven, turning on, cooking, and turning off. So you can see here kind of the power of the interface. Basically, it allows me to use the functionality of a class without actually knowing what is in that class and how that functionality is implemented. And this relates to basically encapsulation. And that means the Samsung functionality is not particularly important for the main class. I don't need to know how the oven is turned on or off. I just need to know that that functionality exists. So I can use the interface without really worrying about what functionality is in the Samsung class. Okay, this will be more and more important as we go along and as we build more and more complex applications. Okay, so that is the interface. Now, a class can implement multiple interfaces depending on what kind of functionality it implements. Okay, in practice, you wouldn't want to implement too many interfaces in a class because of the principle of separation of concerns. You want one class to kind of handle kind of one thing, not too many things. Otherwise, it will get too bloated, too big, and hard to maintain and debug, right? But it can implement as many interfaces as you like. Now, an interface has no constructor. We cannot build an object from an interface. It can implement methods, but doesn't need to. As we've seen here, we implement cook, but we don't implement turn on and off. And if we implement the method, then in the class, we don't actually need to override that particular method as well. Okay, and an interface cannot initialize values, but can update them. So here in my example, the temperature value cannot be initialized. So I cannot say 100, right? That will give me an error. However, I can update that value here. So I can say temperature equals 200 in my functionality, right? I cannot, let me just leave that with a comment. So I cannot initialize values, but I can update them. And also an interface can inherit from another interface. So we can have a chain of interfaces similarly to how classes inherit from one another. The interfaces can inherit from one another as well. All right, so I think that is all for the interface. Again, this is a concept that requires a lot of practice. So we will look at it constantly in our code and in our applications. And you will get used to it more and more as we build our projects and as we go through our code. Hey everyone, so in this video, we're going to talk about standard functions. Now, standard functions are also called scope functions. And the reason for that is that they execute code inside a particular scope in the context of an object. So what that means is that within this scope, you have access to certain variables and functionality, especially variables that you create within this scope. They will be limited to it and not available outside. And that is true for the functions that you create, the variables that you create, and so on. Also, we execute it in the context of an object. So that means that we might have, and I say might because it is optional, we might have an object available within that scope that we can kind of apply our functionality to. Okay, so it creates a temporary scope, temporary because the scope will be destroyed when the functionality of the standard function will finish. And then you can access the original object if there is one. Like I said, it's optional, but if there is one, you can access the original object within this scope. So we have about, I think, 4 scope functions, and then 2 more functions that I have added here that are kind of related to the standard functions as well. So let's go through them one by one and see what they do. So the first one, and probably the most common one that you will see in code, is let. So let allows us to run code on an object. And importantly, it allows us to run code on an object if we have a value in that object. So if it is not null. If the object is null, then the block of code will not run. But importantly, it will not give us an exception, right? So that means we can use the let function to selectively apply functionality to an object that is not null. Okay? Within the let function, we can access the result, so the original object, with the keyword it by default. And I'll show you what I mean by this. So let's go ahead and create a new file. And I'm going to call this let.kt. Okay, so for the let.kt, first of all, I want to create a function getName that will return me a string that can be null. Okay, and I'm going to assign by default a value Alex. Okay, and we will see shortly why that is. Now, inside my main function, what I want to do here, I want to apply some functionality to this result if it is not null. Because if it is null, then I want the system to simply continue on with the processing without crashing, right? So what I can say here is getName $.let. Okay, like I said, this function is applied on an object, and the object is going to be the string that is returned from this function. The string is an object, like I mentioned, everything in Kotlin is an object. So here we are applying let to the object string, but we are applying it if it is not null, right? So here I can say print line, something like hello $it. Okay, so like I mentioned, we can access the object with the keyword it. Or we can also rename that variable. So I can say name instead of it, and then I can use name to access that functionality. So if I run this, since the object is not null, I'm going to get hello Alex in my output, right? But if the object is in fact null, okay, let me correct that. So if the object is null, then the system will not crash, but it will simply skip this functionality. So that is the let function. That is what it allows us to do. Now, before we move on, I want to give you another example here because this applies to other kinds of objects as well. Basically, it applies to all types of objects, but I want to give you another example just to kind of have a better idea. So here, I want to define a animals variable that is a array list of some animals. And I'm going to put cat, I'm going to put dog, and I'm going to put mouse. Okay, now here for this animals, I want to apply a few different functions before I move on to let. So I want to apply a .map. Let's say I might want to get the length of each particular element, right? So that after this function, I will get a list of integers. Now I could apply, for instance, a .filter here for elements that have it greater than 3. For some reason, maybe I have this requirement in my application. And then finally, I will apply the let function. And I just want to simply print line print line, the size of the list is $it dot, I think it's size. There we go. So this will turn into a list, but this will filter my list for elements that are greater than 3. So I think by the end of it, I will have only one element. Okay, so this is another way to apply the let function. There we go. So the size of the list is 1 because we have filtered for lengths greater than 3. All right, so that is the let function. It's one of the most used functions, standard functions out there, so you will see it a few times in code. The next one is with. Now, the with function will allow us to perform a block of code on an object. And the context is available as this. Okay, so this is the keyword. It is optional and can be omitted. So here, let me go ahead and create a new file for my with.kt. Okay, I have fun main. Okay, now here, I'm going to create a with function. And importantly here, I need to pass the object that I want to apply this functionality to. So here I want to simply create a new object of type car. The car class has been defined earlier when we spoke about OOP. So I'm going to just reuse that. If you don't have it yet, just type it out from here. Okay, so go back to with. So with this particular object, I'm going to simply perform some functionality. So I am creating my my scope here. I have the this keyword, which refers to the object that I am applying the function to. And then here I can do whatever I want with it. So I can say model equals BMW because the car has model and top speed, right? So I can use that as well. Top speed equals, let's say 150. I think this is a val, so I need to change it to a var so that I can update it. Okay, and then I might want to say start to apply some, to access some functionality. All right, so if I run this code now, I will simply get the functionality for this object, starting the BMW. So you can see here that we are basically applying some functionality to our object without creating a variable, or we are actually instantiating it, but we are not doing anything with it. We are just applying this functionality. So we can access variables and methods within the object. And the typical use for the with function is to perform some kind of initialization on an object, or just simply apply whatever functionality we require, right? Those are typical use cases. Now, the run function is very similar to the with function, except that it invokes as an extension function, okay? So the extension function will basically say, actually, we haven't talked about extension functions, but what that means is basically run will kind of invoke as a regular function of that particular object, even if it is not defined for that object. Okay, so let's go ahead and create a new file here, and I'll show you what I mean. Run.kt, fun main. All right, so for the run function, let's say we create an object and I want to apply some functionality to it, and I can use the run function. So I can say .run, okay? And you can see that the run function doesn't really exist in the car. It's a generic standard function that can be applied to any object, right? Car doesn't actually define any run function here, but we can still use it to run this functionality. So here, for my car, I can say model equals BMW. And again, I can use the this keyword, right? So very similar to the with function, but ran in a slightly different way. So top speed equals 220, for instance. Okay, and I can just start my car. Okay, so the run function allows us to apply this functionality, and I can say here my car equals my car, right? So I will have a myCar object at the end of this run function. There we go. So I have, I need to actually return it. So I have this keyword. So at the end, the final instruction, if I use this, I will simply return the object. Okay, so I will run this and then I get my car instance. Okay, and then I can use my car afterwards in whatever functionality I would like. So it is useful when you need a lambda that returns a result. So as we see here, we can return this myCar function, myCar object, and can be used to limit the scope of variables. So if I want to apply some functionality only in that particular instance, then I can limit that scope. Now, moving on to the next function, it is apply. Apply can be used to apply some functionality and return a result, and returns the initial object. The common use for apply is to apply some configuration when we create an object. So in actuality, apply is very similar to run, and actually it is very similar to the next function that we will talk about. The only difference is kind of the convention and the use case that we use them in, right? So the differences aren't that great. They are quite subtle, so you can actually replace one with the other. It's just that we have some common agreed upon use cases for each of these functions. Right, so let me just create a new file here, apply.kt, fun main. Okay, now I have again myCar, so let's say val myCar equals to create the object dot apply. So here, let's say I want to apply some initialization, so model equals Ferrari, and top speed is going to be 300, and then I want to drive, and I need a speed, I have 200 here. So here basically I just create my object, very, very similar to how I use the run function. If I run that, I will get the driving. One thing I forgot to mention about the run, which is slightly different from apply. So let's go back a little bit to my run. The run is also possible to use the run function to create a single scope that you want to, use one time in code without storing it and using it later on. So here I can simply say run. Okay. And with that, I have created a scope that will be destroyed after we move on from it. But simply here, I can do some small processing if I like. So here, for example, I can say val new car equals car, and then new car dot start. Okay. Now, once I get out of this scope, I cannot access new car anymore because it will be restricted to this scope. So run allows us to do this. The other standard functions might not allow us to do that as well. Let me just run this since I've added code to it and just make sure that everything works. Starting the null because by default the car name is null. Okay, so I can update here if I want to. All right, so that is the apply function. And we're going to move on to our final standard function, which is the also. Again, here also very similar to apply, except that the convention here is different. And the convention is that we use the also function to basically add some functionality that doesn't really affect the object. So here we have the example of logging or debugging, right? So we want to add some extra functionality that doesn't impact the values and variables inside the object. We just want some extra stuff attached to it. Okay, so let's add a bit of also here. I'm going to use the same file as apply, and I can say here also I have some print line logging the car, and I have here my car. Sorry, we use the it keyword here. Okay, or I can say car. to rename the parameter, and then I can use car here. Okay, so we use this apply this also function for logging. Okay, so let me just go ahead and run. Okay, I log to the console, obviously, but you can log to some file or whatever you like. So these are the main standard functions that we have. All right, so I forgot about this. Remove an also block should not affect the execution of a program. Again, that is the convention. So those are the standard functions that we have. I'm going to talk about two more, which are the take if and take unless. So the take if is very simple to understand. It returns an object if the predicate values to true. Okay, so if we have some functionality that returns true, then the object is maintained. Otherwise, it will return null. Okay, so here, let me just create a new file. Take if.kt fun main. Okay, so I want to create a number and I want to use a random number. Now, we haven't talked about this. We might talk about it later on. It's not really related to standard Kotlin. It's just a way to create a random number. The way you create a random number is you type here random, and you can see that you will get some suggestions. And I will select using the up and down keys. I will select the kotlin.random and I will hit enter. So what this does is it will import an external library, kotlin.random.random. Okay, we haven't talked about imports and packages yet. I have saved that for after the object-oriented programming discussion. So we will talk about this later on. But for now, we're simply going to use an object from this, this library. Okay, so I'm going to say random.nextInt. Okay, here we will simply get a integer. Okay, nextInt, right, so random.nextInt will simply generate us a random integer. So I can say val even or null, and here I have my number dot take if. So I only have something in my variable if it, which is number, %2 equals 0. So if my number divided by 2 or modulus 2 equals 0, then it is even, and then I shall have something in my variable. Otherwise, I will get a null. So here I can print line even or null. Okay, so let's see what we get. Since this is random, I'm not sure what we will get here, but let's see. So we will get an even number. If I run it again, an even number again. It's an integer, so it can be negative. I only get even numbers, so let me try. There we go. So I get a null if it is a odd number. Okay, so that is take if. Now take unless is very similar. It only returns the object is if the predicate values to false. Okay, so I can actually use something very, very similar here. Val, here I can say odd or null is going to be number.take unless it %2 equals 0. Okay, so I will get only odd numbers here or null. Print line odd or null. So now as it stands, whenever I get a number, I will get one of these two here, right? So this one was even, this one was odd. Okay, we can see that we have an odd number. Okay, so also quite useful. They are very similar. They just do things kind of the opposite way to each other. All right, so I think that's all I wanted to talk about in this video. There's quite a few different functions, and you will see them kind of peppered around the functionality that we will study and the applications that we will work on. And then out in the wild, you will also see them on occasion. So it's important to kind of understand what each of them does. Okay, so in this video, we're going to talk about the different types of classes that we have in Kotlin. Okay, and I have listed here about 5 extra types of classes, each with their own kind of property and special use cases. Now, the first one we're going to talk about is the abstract class. If you're coming to Kotlin from, let's say, Java, where abstract classes have quite a big role, you might be surprised that in Kotlin, abstract classes and interfaces are starting to be quite similar, right? So you can implement, for instance, some functionality in an interface and in an abstract class, something you couldn't do in Java. But here, abstract classes still have their own use case. So what are abstract classes? Basically, they are classes that cannot be instantiated, and they are only used for providing kind of hierarchy and aggregating common functionality, right? So cannot be instantiated, provide shared abstract functionality, and they are very similar to interfaces with some very small differences, right? So for example, in an interface, we cannot have a constructor, whereas in an abstract class, we can have it. So let's go ahead and try it out. And we're going to implement here. I'm going to create a new file, abstractclasses.kt. And we're going to implement an abstract class. We do that with the abstract keyword. So abstract class. And I'm going to create an engine class. Okay, and I'm going to create a constructor here. I'm going to have RPM, val RPM of type int. Okay, RPM, rotations per minute, it's basically one of the measures for an engine. And I'm going to implement some functionality, fun run. And here I can just print line something like engine running at $RPM. Okay, so that basically allows us to have an abstract class. Now, I want to first show you here that I cannot instantiate this class directly. So I can say val eng for engine equals engine of 1000 RPM. That's not going to be allowed. Cannot create an instance of an abstract class. So in order to use an abstract class, we need to implement it in one or more regular classes, right? So I have a class, let's say GE for General Electric, GE engine. Okay, that will implement my engine class. Now, importantly here, engine requires a parameter for the constructor. So I need to pass this parameter here. So for that reason, I need to have a parameter in the constructor of GE engine as well, right? So here I'm going to have val GE underscore RPM of type int. And I'm going to pass that parameter GE underscore RPM to my engine. Okay, now GE engine just has one function. Let's call this start, print line, starting engine. And then I'm going to use the run functionality from my abstract class, and I'm going to use it here. Okay, now I have my regular class that implements my abstract class, so I can go ahead and create a parameter or a variable, eng equals GE engine with 1000, and I'm going to say eng.start. Okay, so I can run that. You also see here that I can say eng.run if I want to. Okay, so I have starting engine and engine running at 1000 RPM. So this is the main idea behind abstract classes. We have a class that cannot be instantiated, but is actually used to provide abstract common functionality. If I have another engine here, then I could use another type of engine. I could use the engine abstract class to share that functionality. All right, so that is the abstract class. Next, we're going to talk about the data classes. So the data classes are kind of a common way to store some data in your application. The reason why we have them is they kind of provide a shortcut, a very useful shortcut, I must say, for storing data within your application, right? We could implement a kind of a quote-unquote data storage class in regular Kotlin classes, but data classes just provide a shortcut for that. So commonly create classes for data. The primary constructor has to have at least one parameter. Okay, so we need one parameter to store the data, but we can have as many parameters as we like and can have a body, but is not required. Okay, so let's go ahead and try it out. Data classes.kt. And here I'm going to have a data class. Let's call it user. Okay, now I'm going to put some parameters in my constructor, but for clarity's sake, I'm going to put them on the next line. So each parameter in its own line. It's not a requirement. You could put everything in one line, but I think this just kind of shows the parameters more clearly. So I have val name of type string. I have val email of type string. And I also have val, let's say password of type string. Okay, so this is my data class. You can see that basically I only have a constructor. I don't have any body. I could put body here if I wanted to and perform some functionality, but I really don't have to if my whole purpose is just storing some user data. So here I can have val user equals user. Okay. And I get the parameters that I need to pass. So I can say John. I can say john@gmail.com. And I can say 1234, which is the world's worst password. Okay, one interesting thing about the class, about the data class, is that you can use the toString function. It is special in that it prints out the parameters. So let's try it out. I'm going to say user. Okay, that automatically does a user.toString. Okay, but it's done automatically, so we can just run that. And then we should see the values of our parameters. There we go. So the .toString is special in that it prints out the parameters like this, which is very, very useful, I think. All right, so that is the data class. Very useful in Android, especially when we communicate with a third-party API or some internet data source that will basically allow us to get information very easily, and we will see that when we get to that chapter. Right, so the next class is the enum class. The enum class basically defines a collection of constants. The constants are objects, of course, and they have properties optionally. So importantly here, they can have properties, but not necessarily. But enums in general are very useful when we are trying to define some constants or some set references that we can then rely to make some judgment in our application. So let me show you how that might work. I'm going to create a new file, enum.enumclasses.kt. And to define an enum class, I'm just going to say enum class, and I'm going to put here color, let's say. So here I have, let's say, 3 colors. Red. Usually by convention, the values are capitalized, but of course you don't have to. Green and blue. Red, green, blue. Okay, so I have my main function, and here I can say when. Actually, let me just put this in its own separate function. Function decide, where I pass a parameter color of type color. Okay, so based on this color, I decide when color. Okay, inside here I have color red. I can do print line, something like you chose red. Then I might have color green, print line, you chose green, and then I might have color blue. Okay, print line, you chose blue. Now, one important thing here is that we don't need to have a default, okay, because the system already knows that we have covered all the parameters in my enum. So that means whatever the value is passed here, it will be one of these values, right? So that works fine. Now here in my main, I can simply call decide of color dot, let's say red. Okay, so if I run this, basically with the parameter that I pass here, I can make a decision. So I chose red. So you can see kind of how color can be used, right? We can use it as a sort of flag with multiple values. We can use it as parameters that we pass to our functionality, and so on and so on. You will see this used quite often in code, so you will get a clearer idea when you see it used in different situations. All right, next up we have sealed classes. Now, sealed classes will define a restricted hierarchy, and they are abstract by default, so you cannot instantiate these classes. So they are kind of a mix between the abstract classes that we have defined and the enum classes that we've just seen, right? Except that, of course, we can add functionality to our class. And they are useful in when expressions, right? So just like enum classes, they are useful for that as well. So let's go ahead and create sealed classes.kt. Okay, so I'm going to add, first of all, I'm going to add an abstract class plant without any definition or instantiation. Now from that plant, I'm going to add a sealed class fruit, which is going to be a plant. So it inherits from plant. Again, no parameters, no functionality. Right, so I have my fruit sealed class. Now, I'm not going to add any functionality to it. I'm just going to use it to define my hierarchy. So for that, I'm going to have another class, let's say apple, that's going to be a fruit with the empty constructor by default. So I have my apple. Now, I also have a sealed class vegetable, which is also a plant. And I have a class, let's say potato, which is a vegetable. Okay, so I have my potato. Now you can see here the kind of structure, the hierarchy I have defined. I have plant at the top, then I have fruit and vegetable, and two instances of those. I have apple and potato. Okay, so I can use this hierarchy to kind of make some decisions in my code. So I can say, for example, fun get plant, which will return me a plant, so the top of the hierarchy, and this will simply say, let's say apple. Okay, I want to return an apple here for some reason. So I have my main. Now val some plant is going to be get plant. Okay, so I have some plant that comes from, let's say, a third-party library. I don't really know what's going to be in this variable. I just know that it's a plant, which is the top of the hierarchy. So here I can say when some plant. Okay, and based on that, I can make a decision. Is fruit? Then I can simply do some functionality. Here I'm just going to print line sweet. Okay. Or I can say is, what is the other one? Vegetable. And I can print line something like tasty. Okay, so like I said, based on that hierarchy, I can make some decision, right? I can say, I can provide some functionality for particular levels of that hierarchy. So let me just run this. This is going to be an apple, which is a fruit. So that's going to print out sweet. Okay, so I hope you kind of see the usefulness of this structure. It allows us to make decisions based on some criteria that we might have in our application. Now, to be fair, sealed classes are not as used as enum classes. You will see these more than sealed classes, at least in my experience. I have noticed that, but still is important to understand sealed classes also if you see them out in an application. And then finally, the last one that we're going to talk about is the nested class. A nested class is simply a class that is defined inside another class. Okay, very simple concept, and the inner class can access the variables of the outer class, and the opposite is true as well. The outer class can use or can create an instance of the inner class just as if it was defined outside, right? The difference is that nested classes will be visible only in the scope of that particular outer class. Okay, so a very simple concept. It's as if basically inside a class we can instantiate everything, so variables, functions, and classes as well. And we can have as many of these levels as we want. So nested classes dot kt. Okay, so I'm going to define here a class car. I think we're about 5. Yes, we've defined 4 classes already. So the first thing I'm going to do, I'm going to define an inner class that is going to be called engine. So inner class engine. Okay, now the engine will have var RPM equals, let's say, 500. Okay, and the engine has a function run, which simply calls on this outer class. So I want to show you here how you can actually access functionality from the outer class. So I need to define a couple of things here. So first of all, I'm going to have an engine in my outer class that basically creates an object of the inner class. Okay, so I can use this engine so the inner class, I can use it in my outer class. But also let's define here a speed equals 100. And I can actually use this speed or change it inside my run, inside my engine class. Okay, so here I can say this at car5. Okay, this will basically access the outer class is going, this at car5 dot speed equals 150. Okay, and I can print line here some message, engine running. Okay, and if I create a function here in the outer class, drive, here I can actually use my inner class as well. So engine dot run. Engine.run, and then I can print line some message, right? So driving at $speed. So you can see here that the outer class can create an instance of the inner class, and the inner class can use parameters from the outer class. So there's a very tight correlation, tight connection between the two. So let me just create a simple object, val my car equals car5, and then my car dot drive. Okay, very, very simple. And that should basically create the object, create the engine, run it. Okay, so engine running, and then I'm gonna print line the new speed that was updated by my engine. Okay, kind of makes sense if you think about it a little bit. Both can access each other, right? Makes sense. All right, so I think those are the various types of classes that I wanted to talk about. You will, of course, see them more and more as we progress through the course. At the beginning, we're probably going to focus on basic Kotlin and more focus on Android related components. But as we move on and we create more complex applications, you will start to see these kind of specific objects later on as well. All right, so that's it. Thank you for watching this video, and I will see you in the next one. All right, so in this video, we're going to talk about Kotlin extensions. And extensions are quite a useful way to add some functionality to your code. So here is the problem that we have and that we're trying to solve. The problem is we have a lot of functionality that is in, let's say, a third-party library or even in the default Kotlin functionality. And we want to add some more functionality to that or simply change it slightly, right? So how would you do that from a, how would you change functionality that is included in a third-party library? You cannot go and modify that functionality. You can only maybe extend it and add it to your project in that way. But even then, you have some limitations where some classes simply cannot be extended, okay, or cannot be inherited from. So that is where extensions come in. They are a way to allow us to add functionality, add some properties or some methods to a class that we cannot own and we cannot modify without the need to inherit from that class. So we're not going to inherit the class. We're not going to add more classes to the project. We're simply going to add the functionality to that third-party library. Add the functionality that is available only in the context of our program. Okay, that's not going to live outside of our project, but it's still very useful for our own purposes. And then the added code can be called in the usual way. So for example, if we extend a class to add a method, we can simply call the method on the objects that are created from that class. Okay, now we have three types of extensions. We can extend functions, we can extend properties, so basically adding functions or properties to an existing class without modifying it. And then we can extend the companion object as well. So let's have a look at how we might do that. Okay, and we're going to create a new file here, extensions.kt. Now, I'm going to take an example of a string. So let's think about the string class. We cannot go ahead and modify that class, and we would rather not implement it in our own string implementation, right? So for that reason, it might be useful to add extensions to the string class. So let's say I want to add a function that will maybe allow me to trim the string slightly. Okay, so for example, I might want to say something like this: fun string.slim. Okay, so this is how I would define an extension function called slim on a type that I do not own, which is string. And let's say I might want to say this.substring. Okay, and I want to take the substring from 1 to length -1. So what I'm doing here is whatever string I pass here, or I call this slim function on, I want to have the substring starting with the second character up until the character -1. Okay, I'm going to assume that this string has at least 3 characters. Okay, we're not going to test for that right now. That's a bug that's kind of hidden in this code, but we're going to just assume it doesn't exist because the purpose is to see how we create the functionality here. Okay, so basically what I've done here is I've added this function slim to the string class. Okay, so if I have my main, okay, and I want to have, let's say, val name equals Michael. Okay, I can now call this slim function on my object, so name.slim. Okay, and what that will do is it will basically return the substring in kind of the middle, right? So let me just go ahead and run that. Okay, so I should get something like ico without L. Okay, so basically I have added some functionality to my string class. Now let's assume that I want to have a property for this class in addition to what is already there. So for example, I would like to add val string dot, we already have a length. So let's add a better length. That's going to be of type integer. And for that, I'm going to add a getter that is going to simply return me 200. No matter what the string is, I want this better length to be 200. So here I can simply print line name dot, you can see now it has better length. Okay, I have added, or I have extended the string class with a property called better length, and that should give me 200. Okay, there we go. And you could add whatever you like here, right? It doesn't have to be an integer. So that is the extension That is how we extend functionality and how we extend properties of a class. And I mentioned also that we can extend the companion object. For that, I'm going to just create a class here, class, let's say book, that has a companion object empty. Now we're going to assume that this is a third-party library. Okay, so we're going to assume we don't have access to this. So that means I can just add my extension function for the companion object. So I can say here fun book.companion.print me, let's say. So I have extended the companion object with this print me functionality. And here I can say simply something like print line book has been printed. Okay, so you can see here that I'm not actually modifying my third-party library. Okay, I assume here that I have no control over this, but I'm just adding the functionality in my project. Okay, I could just as easily move this to a new file, but we're going to keep it simple like this. And then here I have book. Since this is companion object, we have static functionality, so I can simply call .print me. Okay, so that should print out the static text here. Book has been printed. So these are three ways in which we can extend existing code in our project only. And this will come in very useful when we are trying to add code to third-party libraries, like for instance, connecting to a remote service, a remote API, retrieving data, displaying data on our Android applications, and so on and so forth, right? Very, very useful. We will be using extension functions quite a lot, maybe not at the very beginning when we're starting to learn about Android, but later on we will definitely use some of this. All right, guys, so in this video, we're going to talk about packages and how they relate to the code that we've built so far. Because we've built quite a lot of code, we've written a lot of code, many classes, but none of them are structured in a particular way. We've put all of them in a single folder, and that can create a bit of confusion. You can see here that we have a lot of functionality, but we don't have kind of an overarching reason for them to be kind of grouped together, right? So this is where packages come in. Packages are simply a way to group related code together. And that can include files, functions, classes, and so on. Whenever we create a class, we have the option to create it inside a package. Now, a package is always the first line of a file. So here, for example, we can define the package where this file belongs to with the package key name, okay? The package keyword. And that is going to be com, for instance, .organization.project.configuration. In practice, a package is going to be a folder on a disk, and multiple packages organized like this are going to be subfolders. So for example, organization is a subfolder of com, project is a subfolder of organization, and so on. We can have as many of these packages as we like, packages and sub-packages. Now the scope, the visibility will be in the same package. So for example, if we have two classes, one that uses another one, they can only be used when they are inside the same package, or if we import them. And we've seen this example for imports. When we import a random number, or we want to generate a random number, we must import that functionality from the random package. Okay, to use code from another package, that package must be imported, and we're going to use the import keyword. Okay, so let's go ahead and try it out in our code. First of all, we're going to create some packages here so that we structure our code a little bit. So under Kotlin, I'm going to right click, new, and here I have package. Make sure you choose package, not Python package or any other package that you might have. I'm just going to choose package, and I'm going to say com.Kotlin tutorial lowercase lowercase everywhere, no capitals at all, and together with a dot at the end, and I'm gonna say pkg. Okay, that's one package. And I'm gonna create another one, new package, and I'm gonna name it very similar. So that's gonna be com.kotlin tutorial dot, and I'm gonna call this one, let's say, login. Now you can see what happened here. I have my com.kotlin tutorial package, which contains two sub packages or subfolders. One is going to be login, where we're going to put a class later on, and one is package, where I'm going to create a new file, and I'm going to call this file something like packages.kt. Okay, now in my packages.kt, I want to simply do something very easy. I'm going to say fun main, and I want to generate a random number as we've done previously, but this serves to illustrate how we import code from another package. Okay, so here I have random. Okay, when I click, wait, let me just redo that. Random, I'm going to choose kotlin.random. Okay. Not the Java one. The Java one works as well because Kotlin and Java are interoperable, but let's choose Kotlin since we're learning Kotlin. And you can see here that we have imported kotlin.random.random. So these two are the package names. This is the class name inside this package. So I'm going to have random here, and let's use next int without a range. Okay. Now I'm going to print line R. Okay, now for some reason my IDE imported this next int, but you can see it's grayed out. It's not actually used, so I can just remove that. Okay, so let me just run this, and that's going to simply generate an integer, and it's going to print it here. So what we've done here is basically we have used some functionality from another package. Now, what I would also like to do is I would like to create our own class inside a separate package and use it here, right? So for that, I'm going to create a new class inside the login package. Okay, so I'm going to say right click new, and this time I'm going to choose Kotlin class. Okay, so I'm going to select class here, and I'm going to say login. Now, when I choose new Kotlin class and I hit enter, automatically that is included in my package where I right clicked, right? So you can see com.kotlintutorial.login, and I have my login class. So that is a class that belongs to this package. So that means in my packages.kt, if I want to use this class, I'm going to say val login equals login. If I hit enter, that's going to generate my import for me. I can type this out as well, but it's easier for the IDE to generate it. Let me just add two parentheses. So you can see here that we have created a package, created functionality inside that package, and used that functionality inside another package, right? We need to import that because the login file belongs to the login package. So here as well, we have the package name and we have the login class inside that package. Okay, so very, very useful. Packages will be basically in every file in Android development. So we will get used to having lots of these kind of imports, maybe dozens of imports for each file that we create. Okay, so very, very useful. We will be using them pretty much constantly. Finally, before we end this video, let's have a look at some naming conventions for packages. So first of all, package names are separated by dots, as we've seen. Names are always lowercase, no underscores, no capitals, nothing, just lowercase words together. If you have more than one word in a package, you might want to avoid that, but if it's more clear, then include two words. Leftmost name is the highest level package and rightmost name is the lowest level package. So we kind of go like from high level to low level package. Okay, we've seen this in our example here. So this is the highest level, This is the lowest level. And finally, we have our functionality here. All right, so I think that's all for this video. Thank you for watching. I'll see you in the next one. All right, so in this video, we're going to talk about generics. Now, generics are one of these concepts that you will pretty much see anywhere you look in the Android system and in Kotlin in particular, right? So generics are basically a way to provide a class with a type parameter. So let's say that a class can handle multiple types of variables. Then we want to be able to specify which type we want this class to handle at this particular moment. And to kind of give you a better understanding, we've actually already used generics before in our code. So let me show you where. I'm going to just create a new file, generics.kt, fun main. Now here, if I say val my array equals array list of strings, right? Now this string is a generic type. So what this says is that the array list can handle a multitude of types. It can handle strings, integers, floats, whatever. But we want this particular array that I define here to handle strings, right? So this is the generic type that I provide to my array list. Okay, so this is going to create a class that can handle strings. In the same way, we can define our own classes that can have these type parameters. Okay, so a type can be used by variables and methods. So we define it on a class and we use it pretty much anywhere we like. And then obviously, it is useful when a class can handle multiple types of parameters, as is the example here for the list. Now, let's go ahead and define our own type that can handle generics. Let me just arrange this a little bit. Okay, there we go. So now I'm going to simply define a class box that can handle any type. So I'm going to just name this T. This is by convention, the type is going to be T, but it doesn't have to be. You can put here anything you like, right? This is just a convention. So the type that we provide at instantiation time T, then we can use this type inside our class. So here I can say fun display, okay, display item of type T that we have provided here. Okay, so I'm just going to simply print line the item. So what this means is that my box class can handle pretty much any type I provide here, right? So what I can do, I can say val my box equals box of, and I can provide a type here, and let's just say I provide a type string. And I'm going to instantiate that class. So my box now can handle strings. So I can say dot display, and you can see here that we are waiting for an item of type string. So I can provide here the contents. But I can also have a your box that is going to be a box of type, let's say integer. Okay, so now when I say your box dot display, we are now waiting for an integer type, right? So we have defined the generic type here. So I can say here 42. So if I go ahead and run this, I should get contents and 42. So you can see that each individual object will handle the different types that we provided. That is the generic. Okay, this is the example. Now, we can restrict the type of generic parameters, right? What this means is that here in my example, I provide a simple type T that can be pretty much anything. But let's say I want a specific type or subtype to be available here. So my class cannot handle everything, but it can handle certain types. So for that, let me just go ahead and define a few types that we can handle. So I'm going to create an abstract class as an example, and I'm going to call this fruit. Okay, I think I've already defined fruit, so let me just call this fruit2. Okay, and I'm going to define an abstract function here, peel. Okay, so that needs to be implemented by the implementing class. And for that, I have my class apple2. Okay, since I've already defined an apple, which is a type of fruit2. Okay, and here I need to, this is a type of fruit2, I need the constructor. So now I need to implement the peel. So let me just go ahead and implement the methods here, peel, that is fine. So here I can just simply print line a message, something like peeling the apple. Okay, so that looks pretty good. Now I want to have a class that can handle apples, right? So here I have my class chef, which can handle generics t. Now here I want to restrict my type to fruit2. So t : space fruit2. Okay, so that is my chef class. Okay, and here I can implement fun cook item of type t, and I'm gonna say item.peel. Okay, so now you can see that chef can handle generics, but only generics of type fruit2, not anything. So it cannot handle strings or integers, for example. It can only handle fruit2. So for that, I'm going to instantiate it here. So chef equals chef of, and here I provide apple2. Okay, and I can say chef.cook, and I need to provide an apple, so apple2 instantiation. Okay, so an object. So if I run this, I'm just going to check that this prints out peeling the apple. There we go. Okay, so hopefully you kind of understand what's going on here. We have basically defined a class that can handle generics of a certain type. So only classes that inherit from fruit2, which we have defined here. Okay, in the same vein, we can provide any kind of functionality, any class, any type generic, right? Also, I wanted to mention before I forget, if I have multiple generics, so for example, in my box T, let's say I have, I can handle 2 different types, I can simply separate them by comma and say T and U. Okay, if I have multiple types. But in this example, I only have one type that I use. Okay, so that is fine. I'm just going to remove that. And I think that is all for generics. So generics are very useful. You will see them pretty much everywhere in Android development. You will sometimes define your own, but it's useful to know they are there when you are using them in classes, or functions such as these ones. All right, so in this video, I have kind of grouped together a few various concepts that don't fit neatly into other sections. However, they are very important since we will see them quite often in our development. So we will talk about them here. Now, the first one is the is keyword. The is keyword basically checks whether an object is of a certain type. Okay, so we are trying to check the class of an object. That will give us a true or false result, and based on that, we can perform some operation, right? So let's go ahead and have a look at an example. Let me just create a new file here for isOperator.kt, and I have fun main. Now, I'm going to create a variable called value equals a string, something like alligator, and I'm going to check if value is a string. In that case, I want to print line the length. So I have an expression here inside quotes, an expression value dot length characters. Okay, so if my value is a string, then I will print out how many characters it has. Otherwise, let's say this is a integer. If I run that, that will not work because the system already knows that this is a string by definition. You can, of course, imagine here we have kind of a common class and we are checking subtypes, and that is where the is will be most useful, right? So if we are checking different subtypes of a class that can be related, then that should work better. Now, the opposite of is not is. So if something is not of a certain class, for that, I want to just create a new class here. I'm going to say class, actually, let's make this an open class car. I think 6, we have 5 other classes. And here I'm going to have another class called, let's say, BMW that inherits from car 6. Okay, and has a simple function drive that will just print line a message driving. Okay, so what I would like to do is I would like to create a function that provides me a car. So I have a fun get car, okay, which will return a type car6, and in actuality it will just return me a BMW. Okay, so based on this, I can see that I have a car, but I don't know which type when I call this get car function. So here in my main, I'm going to have my car equals get car. Okay, and here I can have a BMW or a car 6. Okay, so now I can say if my car not is BMW, then I can print line a message, something like this is not my favorite brand. Okay, so in this particular case, we have a BMW, which means that this will be false, right? Because my car is a BMW, so that will not be printed. Let's try it out. There we go. So it's not printed. But if here we return a car 6 instead of a BMW, then this is not the correct type, so this will be printed out. Okay, I hope that makes sense. And similarly, we can say here, if my car is BMW, print line, something like awesome. Okay, let's just put this back as a BMW. So this will not run, but this will run since my car is a BMW, and I print out awesome. Okay, I hope that makes sense. Let me just leave this here as well. Okay, so that is the is operator. Now we also have the as operator. So the as operator basically will convert one type into another. Okay, it's very simple. I'm going to try it here with the car and BMW that I have. Now I'm going to say my car as BMW dot drive. Okay, so I will just convert my car into a BMW. My car is also, is a BMW anyway, so this functionality in our example, since we are returning a BMW, doesn't really do much. If I had my car 6 here, then we will see a error, okay? Because we cannot convert car 6 into a BMW. We could convert BMW into car 6, okay? Because the subtype can be converted into a larger type, but a larger type cannot be converted into a smaller type or a subtype, right? So this is an error. Car 6 cannot be cast to class BMW. So in order to solve this error, we have another operator, which is a null safe as operator, which is as question mark. Okay, so that means if we can convert it, we're going to convert it, otherwise not. So this will basically solve our problem as question mark BMW dot drive. So in this particular case, I need a question mark here as well. So in this particular case, the result of this operation would either be a BMW or a null. So that's why we need the question mark dot operator here. So running that should not run, okay, because my car is a car 6. But if I have my BMW, then that should work just fine. There we go. So I have driving. Okay, so I hope that makes sense. We can convert one type into another type as long as the type we're converting into is larger, is a super type, right? All right, the next one is late init. Late init basically allows us to create variables that are not null, but are not yet initialized. Okay, now late init basically forces us to initialize the variable before using it, but also it prevents non-null exceptions, not null errors. However, there is a big catch. This kind of circumvents all checks within Kotlin. So that means accessing it before initializing it will throw an error. So we as developers here have to be really careful not to use it wrongly. Okay, it can be used only on var variables, which kind of makes sense because we need to be able to change the value of the variable. And then we can use .isInitialized to check whether the variable is initialized or not. So let's go ahead and try it out in our code. I'm going to have a new file here, lateinit.kt. Okay, now I have my main function. And I have a late init var network service of type string. Okay, so now my network service is not null or cannot be null, but is also not initialized. I can have a function get network service here. And this will simply return a network service string. So let me just initialize the variable get network service and then print line the network service. So this will work just fine. Let me just run it and then we will discuss it a little bit. Okay, that should work just fine, network service. So you might wonder, why do we need this late init variable as long as we initialize it here? Well, in actuality, we might have situations where we know that a variable will be provided, but we also want to be able to access that variable before, or to handle, kind of pass it around in our application before we actually get the value. Okay, so it is very useful, especially with network services. That's why I kind of put this here. With network services, it's quite common to use late init variables in some situations. Okay, just be very careful here, because if we don't initialize the variable and we use it, here we use it to print out a message. If we use it, then it will crash our program, right? So it says late init not initialized. So very, very big issue here. It allows us to circumvent the checks, but we need to be very careful as developers. So I would say use this as little as possible, but sometimes it is quite useful. The common use case is dependency injection, where we will actually see later on what this means, but basically it means we are injecting an object into a class without instantiating it locally. And that is useful for unit testing as well, right? So late init variables, both these common use cases. And then finally, the last concept we're going to talk about is lazy variables. So lazy variables are basically variables that are initialized when needed. Okay, they are useful to save memory in case the variable is never accessed. So the difference between late init variables and lazy variables is that for late init variables, we manually initialize them later on in our execution, whereas for lazy variables, we already provide the way to initialize the variable, but it will not be used by the system unless the variable is required. Okay, and to kind of illustrate that point, let's go ahead and create a new class here, lazy variables.kt. I have my fun main. Okay, so let me define a lazy variable. So val some large variable, which is of type string. And we have the operator by lazy. Okay, and we can see that we have a lambda expression here, and I'm going to simply provide a value, a large value as a string. So obviously this is not a large value, this is just a string, but we can just assume that this is some third process that takes a long time to complete and is quite resource intensive, right? So the large variable will use a lot of memory and a lot of processing power. So that's why we might not want to run this lambda unless we actually require this variable. Okay, so if it's not required, it will not be called. If it is required, then we are going to initialize it. So for that, I'm going to have a val random number equals random. I'm going to import the kotlin.random.nextInt, and I'm going to use this random number. I'm going to say if rand%2 equals 0, then I'm going to print line my sum variable. This is just to kind of illustrate that there are variables that we sometimes might need and sometimes might not need. Okay, so let's go ahead and run this. And sometimes this will be printed, sometimes it will not. For instance, here it was not printed. Running it again, there we go, it was printed, so we did use it this time. So it was initialized. So that is the lazy variables. These are very useful when we're communicating with resource intensive processes like databases or some image processing, video processing in our application and so on, right? So very useful for those use cases. All right, so we have reached the end of this video. Hopefully you have a good understanding of Kotlin, how to use it, and I do encourage you to practice a lot all the concepts that we have learned here. If you've reached the end of this video, congratulations, that's quite an impressive feat, and I hope you got a lot of value from it. And now, finally, I would like to remind you that if you want more information both about Kotlin development and Android development, feel free to check out the links in the description, where I will post the links to my courses both on Kotlin and Android development. They are quite extensive. There's a lot of information there, a lot more than I can cover in a YouTube video. So do check those out if you're interested. But in any case, thank you for following along. Thank you for watching the video. Please subscribe if you haven't and like this video just for the YouTube algorithm. Thank you again, and I'll see you in the next video.